As a part of today's session, we are going to discuss about Jamovi software. So basically, we are going to have basic understanding of what is Jamovi and what are the features of Jamovi, how one can install Jamovi. And after installation of Jamovi, I'm going to discuss about interface of Jamovi. So we'll discuss basically certain features, what are the different kind of statistical analysis one can conduct, what are the different windows one can able to see as a part of Jamovi, and how one can enter the data manually, as well as how one can import the files. These days, many of us are collecting data by using online forms, Google Form. So we are going to look at it, how manually one can do it, how one can also import the files, how one can save the files, how we can open the files. And we're also going to discuss about certain characteristics of Jamovi features like data transformation techniques. So as a part of today, by end of this particular today's session, you are able to understand how to install it and what are the basic features of Jamovi, and especially what are the basic data transformation techniques one can use it. Now, before downloading the Jamovi, what is Jamovi is all about? I'm sure the scholars, the participants, those are here right now. I'm sure you might have attended various programs like SPSS, quantitative data analysis using SPSS, or quantitative data analysis using R, right? You might have seen even JASP. So there are so many softwares are available. Now, when it comes to the Jamovi, it is a free and open source software. I can say that Jamovi is one of the best alternative to SPSS. Now, when it comes to the SPSS, one has to put a lot of investment. So every individual may not able to afford to buy Jamovi, SPSS software. But when it comes to the Jamovi, it is a free and open source software. It is a third generation software. It is a third generation software. And for example, we all know that our software is a free software. Jamovi is the product of the R software. But only difference is that when it comes to the R software, one should know how to give the coding. If you're not good at coding language, if you want to use the R software, one has to learn coding. Especially the members or research scholars, those are coming from non-engineering background or non-coding language background. We always feel something is difficult. Now, by using this particular software, one can do data analysis, starting with the descriptive statistics, inferential statistics. I'm also going to show you a couple of features of Jamovi. It's not just about descriptive statistics, inferential statistics. One can also carry structural equation modeling. As a part of Jamovi, we have various modules are available, right? Now, in addition to data analysis, Jamovi can also be used for data visualizations. Basically, as I mentioned it initially, it is the outcome of our software. It is basically graphic user interface. So one can also use various data visualization tools, data plots, different kind of charts by using Jamovi. Data manipulation, which I'm going to talk about it, certain data transformation techniques, one can use it. Statistical modeling, you can use advanced level statistics, name it any statistics. Most of the modules are available in Jamovi. And results interpretation, it also provide you best results in terms of scientific results it will provide you. And some of you might be knowing there is a concept called meta-analysis. Systematic literature review, bibliometric analysis. We also have one more concept, meta-analysis. Now, if you're going to use Jamovi for writing, for doing meta-analysis, along with your results, it's also going to provide you interpretation. Means if I'm going to use Jamovi as a part of meta-analysis, I don't need to use my own interpretation skills. It is going to provide you it's going to give the results. Simultaneously, it's also going to give the conclusion. It's also going to interpret how one can write it. There won't be any plagiarism issues as well, also in that case. So, this is a basic introduction about Jamovi. Coming to the importance of Jamovi, Jamovi software is found to be simple, flexible, easy to learn. As compared with any other software, Jamovi is one of the most flexible and simplest software. One can learn it within a short time. One can learn it. Okay. Jamovi is highly recommended for users of R, SPSS, or SAS, as they will find interface user friendly. Even if those are good at SPSS, they can easily use Jamovi software. Those are good at Excel sheet, they can also use it, Jamovi software. Jamovi project was founded to be develop a free and open statistical platform which is intuitive to use and can provide the latest development. Name it any statistical technique that you want to use it, one can find the modules as a part of Jamovi software. Data sets in a range of formats. For example, as I'm going to collect the data by using online forms, Google surveys, if I'm having my file in the CSV format or R format, for example, if I want to, one of my colleague was working on our software. If I want to import the particular file in my Jamovi, I can import it. I can import SPSS file. I can import starter file. I can import SAS file. So there are it's completely flexible. So there are a lot of options are available. You can import different kind of formats, different kind of text. I request other members, please check your mic. Unless until there are no questions, you can mute yourself. Okay. Now, I believe that most of you are working simultaneously along with me. If yes, please open your Google. I hope my screen is visible to all of you. Right now, I have opened the Google. Is it visible?
Yes, sir.
Yeah.
Yes.
Please type Jamovi software download. Just simply can type Jamovi download. Okay. The moment you type Jamovi software download, just click enter. You can open first search engine. You can open the first search engine. Okay. I hope you are all there with me. I'll go very slow. Feel free to stop me. Okay. I can repeat number of times as per requirement. Okay. Now, this is Jamovi website. I request all of you to please explore what are the features. Though I have explained very briefly, whenever your time permits, just click on the features of the Jamovi. One can able to see how Jamovi can help you. In what are the way one Jamovi can help you in terms of performing statistics, in terms of conducting your research work. As I mentioned it, one can use statistical technique, one can use it for data visualization techniques, one can also use it teaching point of view, R language. So there are a number of options are available here, features. Now, when it comes to the products, just click on the products. We have two types of products, Jamovi Cloud, Jamovi Desktop. We're all going to use right now as a part of this workshop, Jamovi Desktop. Jamovi Desktop. The moment I click on Jamovi Desktop, it is showing me there are a number of versions. Right now, I'm using as a part of my laptop Windows. Some of you might be using Mac version. Some of you might be using Linux. Some of you, there are the different versions we have. Within Windows, again, there are two types of Windows are available, like current, Jamovi, and Solid. So it's always better to go with Solid. Why? Because current is nothing but it is a completely dynamic. They keep on updating the software. So you may find some differences in terms of the statistical part. As the software developers, they keep on working on it. When it comes to using for your research work, one can rely on Solid. Jamovi Desktop, Solid, one has to download it. It is recommended to use that is Solid version. Second point, whether are using Windows or Mac. Okay. Now, as I'm using Windows, that too, as we are going to with the Solid version, just click on Solid. Okay, just click on Solid, and you can able to start downloading it. It will take hardly 1 minute or 2 seconds. Those installed successfully. Just ensure that you are going to start with, as you can see at the bottom of my cursor, I'm keeping at the bottom of my status bar. Here I'm going to type, either I can type it or I can keep my cursor here. Instead of opening directly Jamovi, if you're not able to find Jamovi in recent files, in search option, just start typing Jamovi. And you'll be able to see the file. I'm just repeating again. After successfully installing the software, instead of directly opening Jamovi on desktop, go to search here as a part of your control panel, as a part of your Windows starting option here. Just type Jamovi and you will be able to see the software here. In your recent apps, in your applications, you will be able to see Jamovi. Just double click on it. Just double click on it. Now, by the time our colleagues will come, I'll just introduce what are the basic features of Jamovi we have it. Okay. Now, if you look at this particular window, we have various options are available, just like any other ribbon bar. For example, if you are opening MS Word, one can able to see file, menu, okay, save. There are a number of options are available. Similarly, when it comes to Jamovi, we have ribbon bar. Like this is the file menu. This is the file menu. As you can see, there are three horizontal lines. As you can see, there are three horizontal lines. This is nothing but file ribbon bar. Just keep your cursor here. You can able to see the moment you click on the file ribbon bar, you can able to see that one can able to create new file. One can able to open the existing file. If you want to import any of the files from your desktop, one can able to do that, like save as, save or export. So just like any other in our day-to-day life, we are using so many applications. So this is a file ribbon bar. So we have open the file, creating new file, save as, special import, and one can also export it, right? Coming to the second option, variables ribbon bar. Just keep your cursor on variables ribbon bar. Just click on it. The moment you click on the variables ribbon bar, you can able to see that one can able to change. You can able to edit the variables. It shows the list of the variables that you have entered. Right now, we haven't entered any variables. By default, Jamovi is showing A, B, C variables. But in case, imagine that you are opening the existing project, one can able to see the list of the variables that you have entered as a part of your Jamovi tool, that particular file. So one can make edit variables, one can compute, one can do transformation, one can add variables, one can delete the variables, one can look at the filters. For example, we have in gender category, male and female. I want to see only male response. We are going to do that particular techniques. We are going to use it. Next one, we have data menu bar, data ribbon bar. In data ribbon bar, like cut, copy, paste, setup, compute, transform, add, delete, right? So these are the same variables we have it. Now coming to the analyze, as I mentioned at the beginning of the session, right now we have just installed Jamovi software. So we have basic statistics are here, like starting with the descriptive statistics, like descriptive, scatter plot, Pareto chart, and comparison based test like independent sample t-test, paid sample t-test, one sample t-test, entire ANOVA family. Within ANOVA, parametric as well as non-parametric, regression test, correlation, regression, logistic regression. So all the families of relation test as well as regression test families, one can able to find here. One can also prepare single frequency cross tabulations. One can also prepare contingency tables, chi-square test. And we also have factor analysis, like principal component analysis, exploratory factor analysis, confirmatory factor analysis. In addition to that, in addition to that, just look at your right side of your window. The participants and the friends, those are not using your laptop or PC. Just look at my cursor here. There is option called modules. There is option called modules. I'm just clicking on the modules. The moment I clicked on the modules plus button, it's showing that Jamovi library and is also showing manage installed, means what are the modules that you already installed, how to manage it. They're also showing that. And so these are some of the options are already available in my current, even you will also might be seeing. So these are the basic features are already there with us. Now I just want to explore what is Jamovi library. Just click on Jamovi library. I request all of you to please go to modules. Just click on the plus button. You'll be able to see there is option called Jamovi library. Just click on Jamovi library and you'll get this particular new window. In this particular window, there are three options. One is the current softwares that I have installed. The current softwares that I have installed it. And these are the softwares already available. These are the softwares are available with the Jamovi. Just look at it. If you can start counting, you can find more than 30, 40 modules are available. Okay. Now, installed softwares. These are the softwares already there with me. These are the softwares already there with me. These are the softwares are available based on type of statistical test that you're going to conduct it. One can install it. For example, I want to conduct SEM, structural equation modeling, or if I want to go for the advanced mediation models, there are so many tests are available. Okay. I'm not knowing many of these tests, so I'm not going to discuss further. But I want to show you that, for example, meta-analysis, as I mentioned at the beginning of the session. Meta-analysis, one can do it as a part of systematic literature review. Meta-analysis is one of the important topic one can learn and one can do it, write the papers, meta-analysis paper. So for doing meta-analysis, there is a software called Major. It is inbuilt in Jamovi. Okay, one can install it. Path analysis as a part of structural equation modeling, one can able to carry out. Okay, and survival analysis, one can do that. As I mentioned it, I'm not familiar with many of the softwares, many of the statistics. Then we also have, some of you might be knowing it. You can also check it out. Those who are looking at this StatCat, please scroll your cursor. Please scroll your cursor. Just find out StatCat. Right now it's showing for me. I have already installed it. I'm just going to update it. In your case, it might be showing you to install it. Just click on install. I'm requesting all the participants. Please scroll your cursor. You will be able to see there is an option called StatCat. What is StatCat? StatCat, for example, I'm very new to the research. As a PhD scholars, I'm not able to understand what kind of test I have to conduct for the data that I have it. The StatCat is going to help us to whatever the data that you have it. It shows for this particular variable, for this particular one variable, two variables, what kind of right choices one can use it. Whether one can conduct correlation test, one can conduct regression test. What are the possible tests one can conduct it? How interesting it is, right? Those are at the initial stage of their research career. You may not be able to understand which statistical text you have to conduct it. But installing this particular software, installing this particular module, StatCat, is going to help you. It will also give you some directions, possible test one can conduct it. For example, I have gender. I'm going to select this particular variable. I'll show you. I'll demonstrate it. I'll select the particular variable. I'll click on StatCat. It will show for this particular variable, what are the tests I can conduct it. Similarly, quantitative data you have it, ordinal data that you have it. So that is one way it is really helpful. You can install it if you want it. As you can see right now here, for me it is showing installed. Those who are working along with me, please install this particular software if you are interested to test this particular module. Okay. Okay. So these are the options available in modules. As a part of Jamovi library, one can able to see what are the softwares are installed in your laptop, I mean in your Jamovi version, and what are the other softwares are available with you. So time to time, one can install it, one can uninstall it. So we have discussed so far about the ribbon bar. So this is nothing but ribbon bar we have explained. We have discussed about it. These are the number of options. Second, this is the processing window. Means here either you are going to enter the data manually or one can import the data. So this is the data window. This is the ribbon bar. This is the ribbon bar, point number 1. Point number 2, this is the processing data window where we are going to process it. This is the what our statistics that you are going to carry. It is going to reflect all our research results here. Now, what happens is if you are using SPSS, I'm sure some of you might be familiar with the SPSS. One can able to see there are two windows: data window, variable view, data view. In one window, we are going to enter all the data. In another window, you are going to get the results, and outcome would be in some other window is going to open. So we have to maintain three different windows. But when it comes to the Jamovi, you are having data in the same window. Whatever statistics that you're going to perform, it is going to show you here itself. Dynamic, it's completely dynamic. For example, if I'm going to prepare descriptive statistics, data will be there as it is here. And I can see the results here. The moment I add cross tab, initially I prepared single frequency. Now I'm going to prepare cross tabulation. It is going to change immediately. So results will be the same, output will be the same, and everything will be on same window. Whether it's Excel sheet, whether take it any other software, you won't be able to find this kind of advantage. You can't be able to see this kind of features. Other softwares we have it. Okay. Now, so what we'll do right now, we'll start enter the data manually. Now, before importing the data, first we'll start entering the data, how to enter the data, how to define the variables, how to define the variables. So first what we'll do, we'll save this particular file. Just go to file ribbon bar, just click on the file. And there's option called save as. I'm just repeating again. I'm just want to save this particular file. Go to click on the file. As you can see that there are three horizontal lines. Just keep your cursor and just click on here. And you'll be able to see this option called save as. Just click on save as. And you can give the title demo. Okay. Demo 1. Just click on save. Now I am able to save this particular file. Okay. Now we'll start entering the data. Before entering the data, as I mentioned it, by default, Jamovi is giving us three options, three different variables. Okay. So what I'll do, I'll just select this particular entire column. Double click on the A. Double click on the A. I'm just repeating again. Either you can delete this particular three variables, or you can make changes. Instead of deleting it, you can make changes. Right now, I just double clicked. For example, I'll repeat it again. As you can see right now, this is the window. I'm keeping my cursor on A. Just double click. The moment I double click, data variable window is opens. Data variable window, it is opening here. Now, in place of A, I just want to type ID of the respondent. ID of the respondent. I'm just repeating again. I want to make changes instead of deleting it. If I want to delete it, what I can do? I can select this particular window. And right click, delete variable. I can delete it. For example, I selected C, right click, delete variable. Delete column C, yes, okay. But if I don't want to delete it, I want to make changes. So whether you want to delete it or whether you want to make changes, select that particular column heading. For example, ID. Just double click on ID. And you'll be able to see that data variable is opened. Data variable is opened. Okay. Now, here there is one more option, description. Here I can type, for example, as a PhD scholar, I'm entering the data and my guide wanted to see how I have given the coding, how I entered the data. Now, as an individual person, if I'm going to work, as it is my data, I can able to understand it. I don't need to write any kind of description. But in case, if you want to meet any expert, if you want to consult your supervisors, and if you want to give some kind of explanation about what kind of data that you have collected it, how you have given coding. So it's always better to give description, ID of the respondents. I can type ID of the respondents. I'm not saying that it is a mandatory. It is going to help you if you're going to show this particular data, if you're going to consult your supervisor, experts in future course of action. Otherwise, as the individual person, you know what kind of data that you have collected it. But it's always better to have some kind of understanding what kind of data it is all about it, right? Second one. Now, when you're going to define the variables, if you go back to our yesterday session, I have discussed about 4 levels of measurement: nominal data, ordinal data, interval data, just 1 minute, nominal data, ordinal data, interval data, ratio data. Now, having knowledge about type of the variable is very important. So Jamovi, one has to define the variable. For example, if you look at this particular here, data variable, after giving the title of the variable, after giving the description, it is asking what type of variable it is. It is asking what type of variable it is. Now, I should know whether ID of the respondent is a nominal data, ordinal data, continuous data, what it is. As a part of Jamovi, we also have one concept ID. So I just clicked it ID, and whether it is text data, decimal data, integer data. So one has to define type of the variable, measure of the variable. Okay, now as it is ID, it is going to be integer. It's going to be have numbers 1, 2, 3, 4, 5, 1 to 100. We are going to have numbers. For example, imagine that right now I'm talking about name of the variable is height. Name of the variable is height. Now there is a possibility that I may get some decimals. So it is going to be like, for example, my height is 5.68. So it is going to be decimals. So I can click on decimals. If I'm going to type name of the variable as a text, male, female, if I'm not giving code 1, 2, 3, I can put it as a text. What I means to say here is that as a researcher, while defining the variables, one should have clarity about what type of variable it is, what kind of measurement it is all about it. One should have knowledge about it. Just look at my slide here for your reference. As I'm going to share this particular slides with you all, you don't need to worry about it. Now, when it comes to the numerical qualitative variables, for example, I'm going to say that gender, I'm going to give the coding male, female, 1 male, 2 female, or maybe 0 male, 1 female. There's nothing like standard. As a researcher, how we are going to give the coding? Accordingly, one can able to give the coding. If you're going to give the coding 1, 2, it is going to be like integer, right? In case we are going to type male, female, instead of giving code 1, 2, there is going to be text. For example, if we are talking about occupations, and if you're not giving any code, 1 doctor, 2 lawyer, 3 engineer, you are simply typing doctor, engineering, lawyer, there is going to be text. So we have to select the variable as the text. As a researcher, you have choice whether you're going to choose how we are going to code. Accordingly, you are going to have choice. Second one, discrete. For example, how many children do you have it? What is your annual income? What is your age? So in that case, you are going to have integer. Like my age is 42, my age is 39 right now. So I can say that my age is 39. This is integer value. But in case we are going to have decimals as a quantity, continuous quantity variable, decimals. Having knowledge about type of the measurement is one of the important aspect of Jamovi. After typing the first variable, please look at my cursor. Either I can close this one, I can go to the second variable like this, or I can do like this. There is an option called go to next variable. I'm just repeating again. After defining the variable, either just I can click on hide. This is nothing but hide. Just if I click it, it will hide the what are the data variable I have made changes. And I can click on second column, again double click. I can come here, like I want to create new data variable. I can create new data variable. I can do this way also. For example, imagine that I have completed second variable, B column. I want to go to C column. I can click on this option, next variable, next variable, next variable. So there are a number of options are available, how one can enter the data manually. Now just come to the second variable. Here, I'm just entering gender. Gender. Okay. Now we can give the description. It is a nominal data. Yes, it's nominal. It is going to be integer. Yes. I'm going to keep it as integer. I'm going to give the coding. Okay. Now, for example, here, right now we don't have data. That's why it's not showing. Right now I'm entering 1, 2. Right. Now just come here. I just entered 1, 2. Now, right now it's showing 1, 2 here in levels. As I have selected integer, it is showing 1, 2. Now I'll keep my cursor on 1. I'll keep my cursor on 1. I'll code it, male. After typing it, male, just click on tab. Just click on the tab. Now, as it is already selected, I just click on tab. It is showing it is already selected second variable. Here, I'm going to type it as a female. I'll repeat once again. Let me come with another variable. I kept my cursor on the third column. I'm just going to create new variable. For that, new data variable. Just click on new data variable. Here I'm going to create new variable. Type of the variable is educational qualification. Educational qualifications. Okay. Educational qualification. After giving the title, if you want to write the description, you can give it. Now, whether it's a ordinal data, nominal data, what kind of data it is? It is a ordinal data. Okay. So I have selected the ordinal data. I have selected ordinal data, and type of the data is integer. Type of the data is integer. Right now, it is not showing any kind of levels here. Right now, it's not showing any kind of levels here. Now, on my screen, as you can see on my data window, I'm typing 1, 2, 3. I'm typing 1, 2, 3. Now, after typing 1, 2, 3, just keep your cursor here. Just keep your cursor on levels. Means I'm asking you to select number 1. Okay. The moment you select it, and now you can start changing it. For example, 1 means, for me, as for part of my research work, 1 means UZ. I'm not typing full name, undergraduate. After typing UZ, just click on tab. Type PZ. Just click on tab. PhD. After typing, don't click on tab. Just keep your cursor outside of the window. Means outside of the levels. Just keep your cursor outside here. Okay. Now I got UZ, PZ, PhD. One more important point here. After typing UZ, PZ, whichever coding that you have it, you can able to see there is option called pin. You are able to see there is option called pin. What you have to do, just click on the pin. Now it's showing in dark color. If you look at the bottom, it is showing empty one. The moment I clicked on pin, it is showing the dark color. Means I have selected, I have permanently made it as a this particular coding part. Now by default, if I delete my data set, by default, if I remove this particular variables, okay, for example, it is not going to affect the coding part that I have done it. Coding is the same. Maybe you might have deleted 10 respondents data, 15 respondents data, maybe entire data you have deleted it. But levels is not going to change because it is the coding part. Next variable. So one can able to create new variables, whatever the data that you have it as a part of your tool, as a part of your research tool, what are the variables that you have it. Let me do one more. Height. Name of the variable is height. Name of the variable is height. Now, please help me out. What type of variable it is? What type of measurement it is? Is it nominal or
Continuous.
it is a
Continuous.
continuous? Now, what type of data we may enter here?
Decimal.
It is a decimal data. It is going to be decimal, right? Height, weight, or what are the measurements tools that are going to have it? We are going to have decimals data. So in that case, you are going to select decimals. So when it comes to decimals, there won't be any levels. Okay. So, basically you're trying to enter the data based on what are the data that are collected. So we're not going to give any coding part here. Okay. Now, next one, in order to go to the next column, either you can click on here, next variable. I hope you understood how one can enter the data manually. Right now, I have discussed only about how to enter the data manually with the different data sets. Just close this particular window. Just open new Jamovi. Now, we are going to discuss about how one can import the data. So this is Jamovi software. I have opened it. Go to File. There is option called Open. Now, the moment I click on the Open, it is showing me there are two options. Whether you want to import the files from your PC, from your laptop, from your PC that you are currently working on it. In case, right now I have given you data sets. Imagine that you don't have any kind of data sets, but still you want to use Jamovi as it's a free software. You can simply install it. You can practice it. Now, Jamovi is providing some sample data files for us. So just click on data library. Just like any other SPSS file or NVIVO, even Jamovi is providing some sample data files for us. Now, the moment I click on open, there are two options are available. First one is PC. means I can able to download, I can able to import data. I can import the files from my PC, my laptop, wherever I have saved it, wherever I have saved my documents that are given to you. Otherwise, in case if I don't have my own files, I can click on data library. Data library is nothing but Jamovi itself is giving some sample data set files. So right now we have 4 different data sets. They belongs to four different academic backgrounds. So you can able to see and you can install it. You can able to complete. You can practice it. But as a part of this particular workshop, I have shared some data sets with you, each one of you. So what you can do, just click on this PC. Just click on this PC. As you can see that the moment you click on this PC, you can able to see there is option called browse. There is option called browse. Just click on the browse. Just click on the browse. And as I was practicing before coming here, so I went to directly to particular destination. But in your case, you may not able to go to particular destination. So see where you are saved your files, from where one can able to download it. So go to particular destination where you have saved your file. For example, this is the file I'm going to import right now. This is a file that I want to import right now. So I have selected this particular file. After selecting this particular file, just click on open. Just click on open. Just click on open. Okay. As I mentioned it, one can import the file from your PC, from your laptop. In case if you don't have your own data, one can also use the sample data set files given by the Jamovi software. Okay.
Excuse me, sir. Can you please repeat it again?
Yes. Yeah. So just this is the file. Okay. Now I just want to import the files. In order to import the files, just go to open. Just click on open. You will be able to see there are 2 options. One is this PC. Second one is the data library. This PC means from your laptop, from your PC, the current system that you are using on it, from the PC, I want to download it. So I click this PC and you can also click on browse if you want to download from your own PC, your own laptop. But imagine that you don't have any of your data, but still you want to practice it. So just click on data library. Just click on data library. The moment you click on the data library, you will be able to see certain sample data files that are given by the Jamovi. So one can just, for example, I want to import this particular file. What I can do, just click on it. So this is a file I have imported. So these are the basically certain variables we have it as a part of this particular data set. Let me show you one more data set. Open data library, tooth growth. Okay. So there are 3 different variables we have. So one can also practice it. If you want to understand what kind of data it is, what you can do, just go to variables. By looking at this particular data, you may not be able to understand it. In order to understand what kind of data it is, how the researcher has given coding part, there is option called variables. There is option called variables. Just click on the variables. You'll be able to see, unfortunately, this particular scholar, they haven't given any description. In case if the scholar gives a description about the data, one can able to understand what. Come to our data set, the data set that I have given to you all. Go to file, just click on open, click on this PC, go to browse and select the file that you want to import it. After selecting the file, just click on open and you will be able to see that particular file is imported in your Jamovi. Now you can keep on expand it. You can minimize, expand. You can able to see there is option. There are 3 dots are there. Whenever you're not conducting any of statistical tests, if you want to see your data, if you want to understand your data, if you are dealing with your data, like data transformation techniques, entering the data, manipulating the data, you can keep changes. As for convenience, you can make changes here. Now, just look at the data that you have it. As a researcher, first of all, one has to understand what kind of data we have with us. Now here we have data with reference to age, designation, annual income. Basically, this is the data of the university faculty members, gender, and how I've also collected data about their loyalty towards their university. We have around 4 statements, Likert scale statements. As you can see, it's showing in decimals. What you can do, in case if it is showing same for you also, double click on here, double click on that, and it is a continuous data. Yes, it is going to be integer. It is going to be integer. The moment I clicked on integer, you can see that decimals 4.0. The moment I changed from decimal to integer, you can able to see the difference, right? Now we have 4 statements, loyalty of employees towards their university. Next one, satisfaction of employees in terms of their performance, in terms of working in the particular university. It depends on the context. Okay, we have 4, 1, 2, 3, 4, 5, 5 statements with reference to loyalty and 4 statements with reference to satisfaction. Now, after understanding the data that you have it, as a researcher, you also need to know how we have given coding. So it's always better to verify what kind of coding you have done it. So what we can do, we can 3 circles we have it. Designation, we have 3 circles. Annual income, 3 circles. When it comes to loyalty, it is showing the scale, like continuous data, like quantitative data. Now let me see what it is. I'm keeping my cursor on age. I'm keeping my cursor on age. By mistake, it is showing that it is showing the nominal data. Is it a nominal data? Is it a nominal data age?
No, sir. Data.
No, right? Now,
Yes,
the
sir.
moment I change from what kind of data it is?
Continuous.
data.
It is a continuous data. Right now, in my data set, it is showing 3 circles. This 3 circle indicates it's a nominal data. But as a researcher, I should know how I have given coding. As it is a not nominal data, it is a continuous data. I'm going to click on, I'm going to make changes. The moment I make changes, the name of the variable, as you can see that I have changed from 3 circles to scale. So it indicates what now how we have given coding. Okay. Now, is it a decimal or integer? It is a integer. Okay. Next one, designation. Designation. What kind of designation we have it? Like, for example, we have professor. Also, we have 4 levels. Assistant professor, associate professor, professor, and senior professor. We have 4 levels. We have it. Okay. So what kind of data it is?
Ordinal.
Ordinal data.
Yes, yes.
The moment I clicked ordinal data, earlier it was showing nominal data. As you can see, 3 circles. The moment I corrected it, ordinal data. So this is a symbol for the ordinal data. Okay. Now here I need to give the coding part. So here I'm saying that 1 indicates assistant professor. I request all the colleagues, those are working along with me, all the participants, those are practicing along with me, please simultaneously work with me. I can give you ready-made data, but you won't be able to learn it. So that is I have given full-fledged data, but still there is something you have to contribute it. Please give the coding part. 1 is nothing but assistant professor. After typing it, just click on tab button. In your laptop, in your PC, there is a tab button. Just click on the tab. Next, number 2, I'm going to code it as associate professor. Associate professor. Again, tab. I'm going to type it as a professor. Again, tab. Senior professor. Senior professor. After typing the 4 levels, keep your cursor outside of the levels. Please keep your cursor outside of the levels. Okay. Please look at here. You can able to see your data changed based on the coding that I have given here. And one more important point that I have mentioned, as soon as you complete your coding part, please ensure that you'll also complete the pin level. Pin level. Okay. I hope I'm going very slow. Is it good enough to go with the session flow? Flow wise, am I slow or not?
Yes, sir, it's fine.
Yes,
Is
sir.
it fine?
It's quite
Good,
good.
sir.
Good,
Okay,
sir.
okay. Yeah, please, please. So after completing that, just keep your cursor outside and you can click on the other variable or you can click on hide. Whichever option that you have it, one can able to do that part. Okay. So this time I'm going to import. Just go to open. Click on browse. Just click on Likert scale. There is a file name Likert scale, demo Likert scale. So as a part of this particular file, we have same data, but we have only Likert scale statements. Now what happens is, as part of our research, we always try to collect the data. Like for example, we have a lot of data, Likert scale statements. We have a lot of Likert scale statements. We always used to have some kind of constructs. You might be measuring in terms of your perceptions, attitudes. Like in our case, we have employee perceptions, like in terms of their loyalty, in terms of their satisfaction. We are trying to measure employees' loyalty as well as satisfaction. Now, there are a number of ways one can use this particular Likert scale data. Now, for example, I just want to, instead of creating simple frequencies cross tabulation, I want to know average for this particular construct, mean of this particular construct. Satisfaction is one construct. We have 4 items. Let's take, for example, this is a construct. This is the name of the construct is satisfaction. Name of the construct is satisfaction. Now we have 4 items to measure this particular construct. Okay. You can call it as items. You can call it as statements. Okay. So we are trying to measure this particular item, this particular construct, and I want to measure overall. Instead of creating single frequencies for every item, what I can do for entire construct, I can get the mean score. I can get the average score. For example, if I want to conduct tomorrow, we are going to deal with the independent sample test. Now, what I'm going to do is I just want to see satisfaction level of the employees, whether it's having based on gender. Are there any differences in terms of male and female? The level of employee satisfaction with reference to gender, male and female, male and female. So gender is categorical data. It is independent data. We have 2 categories, male, female, and we have satisfaction is a dependent variable. We have mean data. So in order to come up this kind of statistical test, in order to convert the Likert scale statements into mean or into average, we have certain data transformation techniques. We have so many. I'm going to discuss as a part of this particular workshop, couple of data transformation techniques. So I want to create average for it. In order to create average for it, what I can do is just keep your cursor at the end of the data set, last column. Just double click. Just double click. I'm repeating again. I want to create average for this particular 4 statements. For that, I'm keeping my cursor here. Double click. I'm going to create new variable. I'm going to create new variable. It is going to be new computed variable. Just click on new computed variable. Just click on new computed variable. Now, I hope you are there with me, everyone. Please say yes, no. Anyone?
Yes,
Yes, sir.
yes.
Yes.
Yes, sir. Yes.
Now, yes. Now I'm going to get the average score for the satisfaction. So type of the variable that I'm going to create, satisfaction, average satisfaction. I can give the code, whichever I can able to remember. Average satisfaction. Okay. So these are new variable that I'm going to create. And you can also give the description if you want to discuss with your supervisors, if you want to consult any experts, anything. Okay. You can write a description of what it is. Now there are certain formulas are available. There are certain formulas are available. Keep your cursor near Fx. Keep your cursor on Fx. Just double click. Please keep your cursor on Fx. Double click it. There are so many formulas are available. There are so many formulas are available. Now, I want to create mean for the satisfaction 1, 2, 3, 4 statements. I want to create mean. So one has to select what kind of test formula that you want to use it, what kind of test that you want to do. I want to create mean value. So if you scroll your cursor, one can able to see there are a lot of options. Options we have it. Like for example, if you scroll your cursor, one can able to see there is an option called mean. Just double click on mean. I'm just repeating. After scrolling your cursor, if you want to do it minimum value, maximum value, mean value, rank value, median, standard deviation, whatever you want to do it. For example, right now I want to do it mean. Just double click on it, mean. Okay. After selecting double click, you can able to see in the formula mean, and it also came with some parenthesis buttons. We have got some brackets. Within brackets, already cursor is there. Now what you have to do is, I want to create mean value for the statement satisfaction. So scroll your cursor, select satisfaction, double click. Please double click on it. Not one click, double click. The moment I double clicked, this particular variable has considered it. Now, just with the help of your uh, window, you can just press comma button, comma. Keep comma. Again, second, just select second one, double click, comma. Select the third one, comma. Select the fourth one. This time you're not going to have any comma. Just keep your cursor outside of the parenthesis button. I'm just repeating again. We are going to create new variable. Name of the variable is average for the satisfaction. There are 4 statements. I want to know on average what is the satisfaction level of the employees. By using the particular score, I can conduct number of tests. I can go with a correlation test. I can go with regression test. I can conduct with a independent sample test. Depends on the variable that you're going to have it. So I need to get the mean value for it. In order to create the mean value, we created new compute variable, and type of the variable that we have given is average satisfaction. I have given the name of the variable, and there are certain formulas are available. As we want to create mean value, I have selected the mean. After selecting the mean, with the help of double click, and we got the mean and parenthesis buttons. By default, cursor is always places within the parenthesis button. Now, one has to select the type of the variable that you want to select it. For example, I want to select 1 to 4 statements. You need to double click. In order to select the particular statement, you need to double click it. And after selecting the particular statement, you need to press the comma. After selecting all the statements, whether it is 5 statements, 6 statements, 7 statements that you have, keep your cursor outside of the parenthesis button. Just keep your cursor outside of the parenthesis button. Just click enter. Now you can able to see the average for the satisfaction average level. One can able to see that. If somebody want to quantify it, you can also count it. 2 plus 3 plus 3 plus 2. How much it is going to come? 2.3. Now you can able to see the average satisfaction for all the 4 Likert scale statements that you have it. 4 Likert scale statement. We got average, right? So this is one type of data transformation technique. One can able to use it. How was the session? Was it helpful today?
Yes, it was very good, sir.
So thank you so much. If you don't have any questions, thanks all for your feedback. Thank you. Thank you. Just open the demo 1. We have opened the demo 1 file. Name of the file is demo 1. Okay. Now here we are going to create some frequencies, cross tabulations today. Before using the frequencies, before preparing frequencies, just create certain recoding. Like we are going to code the gender. Just click on the gender value. We are going to give it as a 1 as a male. We are going to code 1 as male, 2 as female. Okay. Now we can pin it. You can pin that. Now we can able to see that values that you have given coding part. 1 male, 2 female. Now I want to create single frequency table. I want to create single frequency table for that. Now just go to analysis. Just go to analysis. You can able to see there is an option called frequencies. We have option called frequencies. Just click on the frequencies. So what are the options that we have it? We have two outcome variables. If you have two variables, one can able to create it. X square, whenever you want to conduct a chi-square goodness of fit test, one can able to do that. Contingency table, one can able to do that part. Okay. Now, in addition to that, there is also option called exploration. This is also called exploration. Just come to the exploration. Descriptives. Just come to exploration. There's option called descriptives. Now here I'm taking the name of the variable is gender. I just want to create frequency table for the gender.
Sir, where is exploration?
In the analyze, first option is exploration.
Yes, sorry.
Yeah. So after selecting the gender, you can drag and drop it here, or you can select this particular gender variable. The moment I selected the gender variable, I can able to see that right side we have a list of the statistics. But I want to not to create any mean value for the gender, nominal data, median value. I don't want. I just want to create frequency table. Now, if you look at the left side in the middle of the window, it is asking how you want to create it, whether you want to create a table across rows or across the column. I can make changes as per my requirement. Right now, I want to create across the rows. Okay. And what are the things I want to create? I want to create frequency table. I want to create frequency table here. You can make changes as per your requirement, whether you want to create the table row wise or column wise. Choice is there with you. Second one, I want to create the frequencies. So the moment I click on the frequencies, it generates the frequency table. Now further, just click on the statistics. Just click on the statistics. Okay. Now here, as a part of my frequency table, what are the things that I want? I don't want descriptive statistics. I don't want to have mean value for the gender. If for nominal data, I don't want to have mean value. I don't want to have median and standard deviation and all. So what I can do, I can unclick. I don't want mean. I don't want median. I don't want standard deviation. I don't want all this stuff. Okay. So even I can delete it, all this stuff. I just simply want to have frequency table. Now I can take this particular table. I can select this particular table, right click wherever you want to right click, just right click. We have three options are available. Whether you want to copy, for example, this is the first table that you have created it, frequency table. Imagine that from last 15 minutes I'm working, I have created around 10 tables. I can copy all tables at a time. I can copy all the tables, all the results at a time, or I can copy only single table that I want to right now do that part. Okay, I just simply can copy it. Okay. Whatever you want to do it, you can choose, or you want to export it, you can able to export it. Where you want to export it? In the form of PDF document, you can able to export it. Okay. But what you can do, just simply copy it and put it in your Word document. Okay. You can put it in Word document. So one can export it, one can copy it in Word document, and you can also make changes here. If you want to make changes, one can able to make changes. What are the alternation that you want to make it? One can able to make it. So as per your choice, one can able to make changes here. Now, next time I want to create some cross tabulations. I want to create some cross tabulations here. So just go back to our data set again. Now we have two variables. First variable is gender, second variable is designation. Now instead of creating frequency tables, only single variable, single graph, charts and all, I just want to create a cross tabulation. Okay. So for that, go to exploration, descriptives. I want to create, some of you also can add to me. Generally, it is suggested that if you have more than two or three variables, if you have more variables, for example, we have gender, second variable is levels of positions. When it comes to levels of position, we have four rows, we had four levels, we have it. It is always suggested that the less variable, for example, gender, we have only two variables. It should take them as a column wise, and the more levels, whatever you have it, that should take it considered as a row wise. I'm not saying that is compulsory, one has to follow, but it looks very good because when it comes to gender, male only, female, we have only two categories. Whereas when it comes to levels, we have four or six categories, seven categories. One can able to see properly. So that was suggested, one of the best suggestion, if you can take it out. Now, when it comes to the designation, I'm taking it as a variable. I want to split I don't want to simply understand out of 100 people, how many people belongs to professor category, senior professor category. I also need to understand there are 100 professors, 100 faculty members. There might be 10 or 20 professors, but how many of them belongs to gender? How many of them belongs to male category, female category? So I want to split by gender. So gender has taken as a variable. Designation I have taken as a variable. Gender, I'm going to take it as a split by. Gender, I'm going to take it as a split by. As I'm going to create frequency table, I can uncheck this particular all the stuff which I don't want to look at it, which are not useful for me as a part of categorical data. Okay, I'm just going to create frequency table. I'm going to create frequency table. As you can see here, I have created a frequency table. Now there are two options as I mentioned it. Variables across columns, variables across rows. I think it's not making any changes, same. So gender, we have taken it, and designation I have taken as a row wise. Gender I have taken as a column wise. So this is how one can prepare a frequency table cross tabulation. In addition to that, we also have number of charts, number of bar charts are available. Right now, I don't want to use any statistics here. I want to use some plots. Now, when it comes to histogram bar, okay. Now, based on the type of the data that you have it, we cannot simply choose what are the chart that you want to create it. We also need to see what kind of data that you have it. For example, right now we have two categorical data. Whether I can go with histogram. Okay. So based on the type of the variable that you have it, one has to choose what kind of charts, what kind of plots they have to prepare it. Now, when it comes to the gender, when it comes to the designation, it is not quantitative data. It is a categorical data. One has to right now, what are the options that are available right now with us? We have only bar plot is the only option that is available for the existing data, like male, gender, and designation. We have only bar plot is available. Histogram, we cannot use it for this particular data set. Histogram, density, box plot, one can only, YLN is another unique data set. Generally, you won't find in spaces. It is a specialty of the Jamovi data we are going to discuss. Okay. Now, just click on the bar plot. Just click on the bar plot. So we have created the bar plot here. Now, if you want to export it, I can export it here. If you want to export, you can export it here. And after exporting, if you can also make some changes. I think I haven't copied it. So this one I have copied it. I copied it as the image. This. Okay. So this is one. Next one. Go to our data set. We have few more variables. Now I just want to create statistics for this. I want to create a frequency table for it. Okay. I just want to understand what is the descriptive statistics and what kind of plots one can create it. Okay. Go to exploration, descriptives. I'm taking average satisfaction. So you can able to see here, we got mean value 2.77, median value 2.75. Okay. Now coming to the histograms, coming to certain plots. Let's see what is histograms all about. So we have histogram. We are able to create histogram. It shows how data is presented here, how data is distributed as per the satisfaction level point of view. The mid value, the mean value, median value should be 0. If you want to see the average, mean is equal to median is equal to mode, it should be the value should be here. Now, when it comes to the histogram plot, this is the way one can able to do that. Now, I also have density as a part of the histogram. Now, when I click on the density, you can see the smooth curve. One can able to see the smooth curve. It's able to show that how data is distributed. Though earlier we have certain bars are available, but it is giving more clarity in terms of smoothing curve. It is helping with the help of the curve, how data is, one can see the fluctuation, one can see the ups and downs of the data, how it is distributed. Okay. Next one can also see the box plot. One can also create box plot. I'm sure many of you might be knowing it. Tomorrow, I'm going to discuss in detail about what is box plot, especially when it comes to normality distribution of the data. So we can see that different quartiles. This is the mid value, median value. We have from this point to this point 25%. That is first quartile. From this particular point to this point, we have total 50%. From here to here, 55%. Box plot will also help us to understand are there any outliers. If there are any outliers, when it comes to understanding normal distribution of the data, one can also use box plot to understand are there any outliers in your data? Are there any data sets which are deviant from your mean? How much they are deviant from your mean value? So box plot will help us to understand how data is distributed, what is the median value. Okay. So we have one more interesting plot as a part of Jamovi. Name of the plot is violin. It looks like violin, very funny and very interesting here. As you can see here, it shows just like it is a part of the box plot. It is just another way of putting the box plot data. It indicates that this particular part to this particular part means there is frequency is very high. The number of whatever average satisfaction we have taken from this particular level, from x-axis to y-axis, if you take from this particular part, this is very broad in terms of wideness. You can see that this is very wide here. Similarly, one can also see here wide. As you come here narrow, this is very narrow. It shows how our data is distributed here. Okay. So it's very interesting. You won't find most of the softwares having it. If you're interested, you can able to present it, this particular data. This is another way to present how data is distributed within the data set that you have it. And within the data, we have two options. One is stacked data. Second one is jittered. Right now, we are seeing the jittered data. Second one is stacked data. I'm sure some of you might have seen, very rarely we'll see this kind of plots in various research research papers, thesis and all. I haven't seen any thesis, but as a part of learning this particular software, I felt it very interesting and very funny. It's better to present sometime, unique plots as a part of your research paper writing part. So we also have QQ plots. Even QQ plots, one can able to use it when it comes to talking about how your data is distributed, whether data is distributed normally or not. As you can see this particular diagonal line, how this particular data is scattered around this particular diagonal line. The data, if it's exactly scattered surrounding this particular diagonal line, it means data is distributed normally. But if you see there are some outliers which is going out of this particular diagonal line somewhere. For example, if you see one data set here, one see data set here, it means they are the outliers. They are the deviants from the mean. But when it comes to this particular data, the average satisfaction level, we are able to see that there is no any problem with the normal distribution of the data itself. Tomorrow I will discuss. We'll have theoretical understanding of what is normality distribution of the data, and we also have practical with the help of the data. We are going to carry it. Good evening, everyone. Welcome to fourth day. As a part of today's session, we are going to discuss about t-test. Now, as a part of today's session, I'll be talking about one sample t-test, independent sample t-test, and paid sample t-test. Time permits, we'll discuss a few more concepts. And I want everyone should practice it simultaneously along with me if you're ready to do it. Okay. Now, coming to the one sample t-test. Before that, I just want to have a brief discussion about parametric and non-parametric. Though I have discussed about it on the day one as a part of understanding basic terminologies, there are two types of statistics: descriptive statistics, inferential statistics. The main objective of inferential statistics is to give some kind of conclusion to generalize the major findings of your study. Now, as a part of inferential statistics, again, we have two types of statistics: parametric, non-parametric. Now, what are the parametric tests we have it? In order to carry this particular parametric statistics, one has to fulfill certain assumptions. Now, if you're going with a comparative based test, t-test, we have certain assumptions. If you want to conduct a correlation test, correlation test has its own assumptions. Means one has to fulfill that particular assumptions, like eligibility criteria. Okay? Whether I can able to conduct correlation test for this particular data. So they have certain eligibility criteria. So as a researcher, one has to fulfill certain assumptions. If you can able to fulfill that particular assumptions, one can go with parametric test. In case if you're not able to fulfill the assumptions, one has to go with alternative statistics. They're nothing but non-parametric statistics. For every parametric statistics, we have some non-parametric statistics we have it. We are also going to discuss about parametric as well as non-parametric statistics as a part of this particular workshop. But today I'll be covering t-test. Now, what are the parametrics that I will talk about it step by step with along with the test that you're going to conduct it. Okay. Overall, we have discussed on the day one, but right now, from today onwards, for each test, what are the data requirements we have it? What are the assumptions one have to fulfill it? Okay. Now, coming to the one sample t-test. As you can see on this particular slide, one sample t-test is a parametric test. Okay. Now, it is also known as single sample t-test. It is also known as a dependent sample t-test. One sample, as the name itself indicates, you are going to have one variable, one sample data that you're going to have it. The main objective of conducting this particular one sample t-test is to compare the sample mean with the population mean. To compare the sample mean with the population means. Means there are two things are here. I'm saying that we are going to compare the sample. The sample is nothing but the data that you're going to collect as a part of your research. And you're going to compare with the population mean. Now, somebody can ask, what is population mean? Now, when it comes to the population mean, for example, if you're referring to elderly population, you were saying that life expectancy rate is right now around 71%. 71 years of life expectancy rate. When India got independence, our life expectancy rate was around 35, roughly around 35. Now one can able to see around 65 to 71, our life expectancy rate is increased. Now, as for the overall from the Indian context, we have don't go by face value. Just I'm saying roughly around 71 life expectancy rate right now from the Indian context. Now, for example, we have Professor Divya. She want to conduct research and she want to understand overall an average population. Overall population life expectancy rate is 71 years. But what about the Gujarat state? In Gujarat state, what is an average life expectancy rate? So she started collecting data from around 5,000 people and 500 families. And she started understanding in the 500 families, on average, what was the life expectancy rate? Now, the 5,000 is the sample. And the overall, I mentioned about 71% is from the all over Indian context. So as a part of population census, as a part of whatever we have NSSO data, we have 71 is the national level average expectancy rate. That is population mean. Now I'm comparing sample mean. The sample is nothing but the data that I collected. I'm just comparing sample mean with the population mean. Let me put it another way. Imagine that you are working in a rice mill factory. Don't take it other way, just as an example. Imagine that you're working in a rice mill factory and you have 50 kgs bag, 100 kgs bag, 200 kgs bag, rice bag. Okay. Now, one of the wholesaler is coming and he want to buy at a time around 50 bags. One of the wholesaler is coming and he wanted to sell it for retail in his region, in his area. So you want to buy bulk so that he can get that cheaper rate. Now you are telling to that person, this is 50 kgs bag, this is 100 kgs, that is 200 kgs bag. Now you can't simply blindly follow whatever you are saying it, right? So they want to take sample, they want to check it. Okay, you are saying there is a 50 kgs bag, just let me verify it. So you want to verify it, you'll take around 10 bags and you will see whether it's really 50 kgs or not. So he'll take small sample to verify whether it's really 50 kgs. Is it really 50 kgs or 19 kgs? Sorry, 49 kgs or 44 kgs. Now, I hope you are able to understand what I means to say. As a owner of this particular rice mill factory, I'm saying this is 50 kgs bag. But the wholesaler, he wanted to take small sample before giving more advanced money, as he's going to buy in bulk, he want to check it out. So 50 kgs is a sample. It is a population mean that you're telling to the wholesaler. And he is going to take around 10 bags, that is sample, and he really check it out whether it's really whatever the rice mill factory owner is saying is really 50 kgs or not. Means you're going to compare the population mean with the sample mean with the population mean. Now, the point here is that in every case, you may not be able to get the population mean. Every case, you may not be able to get the population mean. Now, here what happens is population mean can be based on certain statistics published by recognized institutions, maybe previously published research articles. It can be hypothetical value, right? So there are certain parameters one can use to determine what is population mean. So based on the population mean, you are going to calculate your sample mean and you are going to compare it. So basically, as a part of the one sample t-test, that is dependent sample t-test, examines whether the mean of a population is statistically different from the mean, means the sample mean of a population is statistically different from known or hypothesis value or not, right? So the test variable is only one variable. In order to conduct one sample t-test, we required certain data requirements. Test variable that is continuous. One has to have quantitative data if you want to go with one sample t-test. And second one, scores on the test variable are independent. For example, I'm collecting data from 20 people. Respondent number 1 data has to be given to respondent number 1. I can't give respondent number 1 data in two places, 1 and 5. So the scores, whatever I'm getting, there has to be independent. Okay. Random sample of data from the population. You must have collected data by using random sample. So that is one of the important requirement for conducting any parametric statistics. Another most common and very important data requirement or assumption is that normal distribution of the data. As a researcher, you are assuming that your data is distributed normally. And you are also going to test it. As your assumption is, for example, you are assuming that your data is distributed normally. If you are able to ensure that your data is distributed normally, you will go ahead with conducting parametric test. In case, if you're not able to fulfill this particular assumption, you'll go with non-parametric test. So second one, lastly, no outliers. There should not be any outliers in the data set. So these are the basic requirement for conducting one sample t-test. Okay. Now, coming to the hypothesis. This is the problem of the statement. Like, on average in Gujarat, population mean height is 66.5. As per the Government of India report, it's roughly, okay, and don't take it seriously. Height of the Gujarati people is 66.5 inches, 66.5 inches. Now, as I'm coming from Gujarat, I'm working in Gujarat. I want to collect the data from the Gujarat state itself. So I decided that I'm going to collect the data from 2,000 people, just to see whether, as Government of India mentioned that on average people in Gujarat are 66.5 inches. I just want to compare it. So in order to compare this particular data, I'm collecting data from 2,000 people in Gujarat. The 2,000 is a sample mean. So here my null hypothesis is that the sample mean height is equal to 66.5. So the 66.5 is the population mean, okay? Whereas the sample mean is the data that I'm going to collect as a part of my research work. Now, when it comes to the alternative hypothesis, the sample mean height is not equal to 66.5. The sample mean height is not equal to 66.5. Now, coming to the data requirements or the assumptions, I need to fulfill 5 criteria. Test variable that is continuous. So we need to have the variable in order to conduct one sample t-test that must be continuous data. Okay. So one has to see that what are the variable that is going to use that going to be continuous data. Scores on the test variable are independent. That is assumed as a researcher, you know how you have entered the data, right? There should not be any kind of mistakes. Random population that also cannot be tested because as a researcher, you are saying that I collected data by using random sample. Now, one can only test normal, whether data is distributed normally or not. Now, in order to understand whether my data is distributed normally or not, as I mentioned in even yesterday's session, there are so many options are available. But as a researcher, one can use one or two tests as a part of your research. Even one is good enough. Like we have descriptive statistics, we have Sperry-Wilkie test, we have box plot, we also have histogram, and we also have QQ plots. So there are a number of options are available. If you go to SPSS, one can also see STEAM and LEAF. So there are more options are available, but any one statistics is good enough to report as a part of your research saying that my data is distributed normally or not. Okay. Now, how to conduct the normality test? As we are going to rely on Sperry-Wilkie test for the entire workshop, at least from my side, I'm going to prefer always Sperry-Wilkie test as a statistical test to understand whether my data is distributed normally or not. Now, when it comes to the normality distribution of the data, my null hypothesis is that the sample is drawn from a normally distributed population. As a researcher, I'm framing my null hypothesis for testing the normal distribution of the data. The sample is drawn from a normally distributed population. Whereas when it comes to my alternative hypothesis, the sample is drawn from a normally not distributed population. Okay. Now, next point here is that we are going to compare the p-value to some predefined threshold. So we have some threshold value. What are the test value that you're going to get it? We are going to compare with the threshold value. Threshold value is 0.05. Okay. Now, how we are going to give the conclusion? How we are going to interpret the findings? If the p-value is less than the threshold, what are the tests that you're going to conduct in order to understand whether your data is distributed normally or not? We are going to come up with conclusion part. If the p-value is less than the threshold, means what are the tests that you're conducting it? If the p-value is less than 0.05, we reject the null hypothesis. Means the sample is drawn from a normal distributed population. We are going to reject this particular null hypothesis. In case, if the p-value is greater than the threshold, that is greater than 0.05, we are going to mention that if the p-value is greater than the threshold, we fail to reject the null hypothesis. So this is how we are going to report as a part of your normality distribution of the data here. So before going to conduct a one sample t-test, what we'll do it, we'll verify whether our data is normally distributed or not. I request all of you to please open your data set. First, open your Jamovi. I'm shifting from PPT to Jamovi. I hope my screen is visible. Yes. Is my Jamovi is visible? I have opened the application of Jamovi.
Yes, sir.
Yeah. Okay. Now I'm just importing the data. Just please import the data. First one we are importing, name of the file is t-test. The name of the file is t-test. I hope all of you must have downloaded the data set that I have given to all. Please download the data set. Title of the file is t-test. Title of the file is t-test. Now in this particular data set, we have 5 variables: ID, gender, athlete, height, mile, minute, duration. So we have data of around 435 responses, nearly 435 responses. We have it. And 5. Now, as a researcher, first what you have to do is once we import the data, please check it whether how we have entered the data, what kind of variables that you have it. I have gender, athlete, height, mile for minute, duration. Second one, how I have given coding. Were there any problems with the data set? So it's a gender, nominal, male, I have given 0. Please remember how we have given coding. Most of the data sets, it is not always compulsory that male is 1 and female is 2. As a researcher, you have choices, but you should know how we have given coding part. Okay. How we have given coding, one has to have clarity with the next variable, athlete category. We have again non-athlete, athlete. Non-athlete is 0, athlete is 1. Next variable, we have height. It is a continuous data, that to decimal data. Next variable we have it as mile per minute duration. Again, it is a continuous data, decimal data we have. So I just verified my data. I don't think there is any problem with that. Okay. So after confirming the data set that you have it, please go to analyze, go to analyze, exploration. There is a first option called descriptives. We have first option called descriptives. Now, when it comes to our one sample t-test, our hypothesis, null hypothesis was we are taking the null hypothesis as a part of the one sample t-test. We are choosing the height. Okay. Now for the height, I need to check whether this particular variable data is distributed normally or not. So please select height, drag and drop it here. Select the variable that you want to test it. Either you can drag and drop it here, or you can select and click on this particular arrow button. Now we got it height. We got the descriptive statistics like mean value, median value, standard deviation value. Just come to the statistics. Please come to the statistics. Scroll your cursor down. And here I am able to see standard deviation, missing values, mean, median. Okay. There is an option called normality test. What was our hypothesis? The sample is drawn from a normally distributed population. That was our null hypothesis. So we are checking this particular null hypothesis with the help of Sperry-Wilkie test. Okay. Now, please click on Sperry-Wilkie test. Just click on Sperry-Wilkie test. As I mentioned yesterday, right now this particular data is in the form of column wise. Now, if you want to make changes, I can put it in the form of row wise so that I can see the entire data in proper manner. So it depends on the researcher how you would like to see the data, whether you want to see row wise, column wise. So it gives me more clarity. I can be able to see that Sperry-Wilkie test, we have two values. As I mentioned yesterday, we are going to rely on the p value. Sperry-Wilkie test p value here, p. Instead of w, we are going to take the values of p. Okay. Now, coming to our threshold value. Whenever you're going to practice this, you can please look at my PPTs. I'm going to share all PPTs on the last day. With reference to day one, I have already shared it. I also shared very interesting, very good reading material. There is one ebook on learning statistics with Jamovi. If your time permits, please take the book, print out of the particular book, and you can practice it. Okay. Now, what is our threshold value? P value is less than the threshold value. If the P value is less than the threshold value, we reject the null hypothesis. Means if it is less than 0.05, we are going to reject it. Now come to our hypothesis, our test result. It is 0.07. So how to understand this one? What it indicates? Anyone?
Data is not normal, sir.
Data is not?
Normal, sir.
Data is normal or not
It
normal?
does not normal because it is greater than the 0.05. Oh, okay. It is not significant. Oh, sir, normal. It shows the normal data.
Okay.
We failed to reject
Okay.
null hypothesis.
We fail to reject
Yes,
the null
yes, yes.
hypothesis. It means that the sample is drawn from
data
a
is normal.
normally distributed. Means our data is distributed
Yes.
normally. So we are going to conclude like this. Since Sperry-Wilkie value is greater than 0.05, we can conclude the assumption of the normality is not violated. Means our data is distributed normally. So one can write as a part of your research paper as a thesis, small line about your normal distribution of the data. Okay. That way we can able to conclude it. Now, so we are able to fulfill our assumption, and we also have one data, that is height is one variable. It is a continuous data, and I'm saying that our data is collected with the help of random sampling. So we are able to fulfill all the assumptions. Now there is one more option here as a part of Sperry-Wilkie test. Now, for example, what happens is the middle of the window gone, the data processing window gone. Every time I don't need to go and start from the beginning. What you can do is you select this particular output result, keep your cursor here, double click, and you'll get it the previous stage, that is processing. I'm just repeating again. The processing window gone back means I'm not able to see the processing window right now here. In order to see the processing window, you don't need to do it again from the beginning. You don't need to start with A. If you want to go back to the previous stage, that processing window, just keep your cursor near results. Okay. And just click on it. And this processing window will come back again. Okay. The processing window come back again. Now, in addition to Sperry-Wilkie test, we also have certain plots. As we are doing for the first time, we'll also explore for this particular height, how histogram is presenting, whether it's showing any kind of outliers, how data is distributed. One can able to see that bell-shaped curve. Okay, so I can able to understand that data is distributed normally. I can also keep density, smoothing curve, like how it indicates clearly that our data is distributed normally. In order to support it further, I can also see QQ plots. QQ plots, like this is the diagonal line. One can able to see that my data is clustered around the diagonal line. There are certain outliers, but still it is not affecting our normal distribution of the data. Okay. Second, I can also prepare box plot. Now, coming to the box plot, please look at my PPT here. Now, even yesterday also I mentioned about it. Box plot, we have certain first quartile, second quartile, third quartiles. One can able to see there are, from this particular data to this particular data point, this is 25 percentile. From this particular horizontal line, as you can see, from this particular line to this particular line, this is 20 percentile of your data. Okay. And from this line to this line, 50% of the data. This is a mid value, middle point. Okay. From this particular point to this particular point, that is 75% of the data. From this particular point to this particular point, we have 100% of the data we have. Now, in case if there are any outliers, it will show outside of the horizontal line. Like for example, here it's showing that 326. Please remember this particular data. Please remember this 326 is nothing but this is the respondent number 326. 326. 326 height is 84.41. Means we have around 65, 66, even 70 also, 77 also we have it. But this is 84, means is one can able to see that it is more deviant from the mean value. Let me show you another value. 397. Just to understand why it is considered as an outlier. Okay. 397. For every data, we are not going to check it. Just for the first test, I'm just wanted to explain in detail every step. 397. Again, here 84.16. 407, it is 83.75. Just for your sake. Right now, what I'm going to do is 397. Here, I'm just 84 is here. Right now, I'm converting this data as 60. I have converted it as 60. Okay. Please see here. You're not able to see 397 data. The best part of Jamovi is that it is completely dynamic. The moment I changed here, by default, by automatically it changes entire data. You're not able to see here right now 397 data set. Means one outlier we have. I have manipulated. That manipulation is not the correct one. For example, imagine that your data is not distributed normally. What are the alternatives? There are two alternatives. First alternative is you can increase your sample size. In case if your sample size is good enough, you can take the call to delete that particular respondent number. If it is disturbing your normality distribution of it, I request the participants Professor Divya, I think it is. Yeah. Now, if it is disturbing your normality distribution of the data, and if your sample size is good enough, you can take the call to delete that particular outlier. But if your sample size is small, instead of deleting it, collect the more data. So these are the two options are available. Okay. I hope the point is very clear. Now, next, we have conducted normality distribution. Our data is normally distributed. Okay. Now, next, go to the next part. Now, as we have fulfilled all the assumptions, we are going with conducting one sample t-test. We are going to conduct the one sample t-test. In order to conduct one sample t-test, as a part of analysis, we have first option t-test. Go to t-test. In that, we have one sample t-test. We have one sample t-test. As a part of the analysis, we have t-test, ANOVA, regression, we have it. Go to t-test. Within that, we have one sample t-test. Just select it. Just select the one sample t-test. And now, which variable that you are taking it? As per our hypothesis, we are going to test with the height. Okay. Select the height and put it under dependent variable. Put it under dependent variable. Now, here we got the result. Next one. This is a descriptive statistics. We have got one sample t-test. Now, I also wanted to see mean difference. I also wanted to see mean difference between sample mean and population mean. Population mean and sample mean. So I need to understand, was there any difference between population mean and sample mean? So just select it. So we got the difference between sample mean and population mean. Confidence interval. Please click on the mean difference. Confidence interval. Second important point here. Test value. Test value. Now coming to the test value, please look at your hypothesis. Our hypothesis was population mean was 66.5. Our population mean is 66.5. So we need to keep 66.5 is a population mean. Our population mean is 66.5. Now just look at here. Now we have selected t-test. We have selected mean difference. We have selected confidence interval. I'm going to explain one by one. And descriptive statistics for this particular height, this particular variable. If you want to prepare descriptive plots, one can prepare it. Okay. Now, coming to the data interpretation part. Coming to the data interpretation part. We'll go with step by step. There are two important outputs, two important results we have it. First one is descriptives. We have total 435 respondents. However, we got the data only for 408, means there are certain missing values, we have it. So total number of people responded to this particular question was 408. For 408, an average age, we have collected data from 435 people. Out of 435 people, around there are a couple of missing values. Total number of people responded is 408. For the 408, if you look at the average height, it is 68. On average, in Gujarat, the data that we have collected from 435 people, that is 408 people, the average height is 68. Okay, so they got this mean value. Now coming to the second test result, that is one sample t-test that we are conducting it. Now, as a part of one sample t-test result, we need to see three important things. We need to see three important points here. First point, mean value, sample mean value is 68. Okay, we got the difference, mean difference is 1.45, means 66.5 minus 68, you'll get it 1.47, means there is a difference between population mean and sample mean 1.57 inches. Overall, on average, Gujarat population height is 66.5, but the data that are collected from 435 people, that is 408 people, their average height is 68, means one can able to see the difference of 1.47 inches difference between sample mean and population mean. But I want to know what are the difference that you are seeing. Is it occurred by chance was really there is a significant difference. So in order to understand that, we have conducted one sample t-test. Now coming to our p-value. Our p-value is less than 0.01. Now, when it comes to the p-value for any test, given the observed data set, the p-value is the smallest level for which null hypothesis is rejected. Now, if you want to understand how to take the call as a part of the p-value, if the p-value that is less than point alpha value, that is, we are going to reject the null hypothesis. Like, for example, p-value is less than 0.05, 0.001. What is this 0.01, 0.05? These are the significant level. Now, as a social scientist, most of the social scientists, what happens is we'll go with 0.05 as a significant value. Now, when it comes to the scholars coming from science, medical science, health practitioners, most of the scientists, those are conducting experiments because they can't take the risk. 0.5 is a really big thing. So they'll go with 0.001, 0.01. Means when it comes, for example, we have as a part of the vaccination, Covishield and Covaxin. If somebody says that we are only confident 95% and the remaining 5% we are not confident, means 0.05. There is a margin of error. One can able to see that. When it comes to the health, when it comes to the life, 0.05 is a big thing. We can't take that much risk. But most of the scientists, medical science practitioners, they'll go with at least. You're not coming with any error, but there's a scope. There can be some kind of margin of error can take place. So 0.001, 0.01, scientists, scholars, scientists, they'll go with. But when it comes to the management, social scientists, humanities, you'll go with 0.05. Okay. If the p-value is less than 0.05, it means statistically significant. Means we are going to reject the null hypothesis. In case if the p-value is greater than 0.05, not statistically significant. So we are failed to reject the null hypothesis. Now, having understanding about this theoretical point, now just please look at our p-value here. What is our p-value here? Our p-value is less than 0.05. It means what it indicates. Means there is a statistical significant difference between population mean as well as sample mean. So how one can write it as a part of your report writing? Our hypothesis population value was 66.5 inches. The average height of the overall adult population in the Gujarat state is less than 0.001, means less than 0.05. We reject the null hypothesis that the mean height of the sample mean, I think there's some error here. The mean height of the sample mean is equal to the hypothesis population mean, that is 66.5, and conclude that the mean height is statistically different than 66.5. Based on the results, we can state the following. There is a significant difference in the sample mean height of the adult population in the Gujarat and the overall adult population in the Gujarat. Means you're trying to compare the population mean and sample mean, and you're able to come up with the conclusion part. The average sample mean height of the adult population in Gujarat state is about 1.5. So how much difference we have it? As I just rounded off it. Instead of saying 1.47, I just rounded it like 1.5 inches taller than the adult population. And how much your confidence interval? 95% confidence interval. Now, what it is, this confidence interval? Now here, I'm saying that there is a difference of 1.57, 1.5. For the sake of simplification, just round it. 1.5 mean difference between sample mean and population mean. Now, as a researcher, I'm confident that lower level means an average 1.5 mean difference between the sample mean and population mean. But if you want to go with the confidence interval, 95% confidence interval means lower level, lower bound means the difference 1.5 you are saying, lower level is 0.95, upper level is 1.99. Means what are the difference? An average 95% confidence interval we are seeing 1.47, but there is also lower level is 0.95, higher level is 1.99. So we can able to say that as a researcher confidently, this is the lower level, this is upper bound. There is a mean difference is 1.5 and it's statistically significant. One can able to see difference between sample mean and hypothesis value of population mean. So this is all about one sample t-test. Coming to the next stage, independent sample t-test. Now, coming to the independent sample t-test, it is a parametric test. It compares the means of two independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. Now, just like one sample t-test, it is an independent sample t-test is a parametric test. And it compares the means of two independent groups in order to determine whether there is statistical evidence. So basically, you're going to take two independent groups, like for example, gender, male, female. There should be two groups. In case, imagine that there are three groups, like male, female, and we also have transgender, we also have LGBT communities. So in that case, one cannot go with one sample, independent sample t-test. One has to go with ANOVA test. Now, in order to conduct the independent sample t-test, we need to have one dependent variable, one independent variable. Independent sample t-test is also known as two sample t-test, unpaid sample t-test. It is also known as two sample t-test, unpaid sample t-test. Now, when it comes to the assumptions, when it comes to the data requirements assumptions, as I mentioned it, we need to have one dependent variable, one independent variable. Point number two, you are going to have dependent and independent, but one also need to ensure that the dependent variable must be continuous. It must be either interval data or ratio data. Basically, it is a metric or quantitative data. Whereas when it comes to the independent variable, it must be categorical data. Secondly, it must consist of only two categories. I'm just repeating again. As a researcher, if you want to conduct independent sample t-test, we need two data variables. One is dependent variable, second one is independent variable. And point number two, the dependent variable must be interval or ratio data, whereas independent variable must be categorical. It means it can be nominal data, it can be ordinal data. Thing is, you should have two categories. You should have two categories. Now, two categories means that basically is the nominal data. Whenever you're going to have ordinal data, one can go with a non-parametric test. I'll discuss it later on. Now, the cases that have values on both the dependent and independent variables means there must be cases. Like, for example, dependent variable must have data. Independent variable also must have data. Two categories. These are the commons, like random sample, independence of observation, normality distribution. Another unique point is that homogeneity of the variance. Earlier, we have conducted, in order to complete one sample t-test, we have conducted normality test, and we also conducted one sample t-test. Whereas when it comes to conducting independent sample t-test, we are going to conduct normality test, we are going to conduct a homogeneity test, and we are going to conduct independent sample t-test. Now, what happens is, as a researcher, you are assuming there is a homogeneity between the male and female. Means whatever the change is happening, same level of equal variance is happening between the groups in terms of their performance, in terms of height, whatever the dependent variable that you take it, you are assuming that there is equal variance among the groups. Now, when it comes to the homogeneity of the variance, the null hypothesis of this test is equal variance assumed. That is, there are no significant differences between the sample variances of two independent groups. The Levian's test was not statistically significant different. If the p-value is greater than 0.05, Levian's test was not statistically significant, means there are no significant differences. Therefore, this indicates that our data satisfy the assumption, means our data must be, the homogeneity of the variance test value must be greater than 0.05 to ensure that our homogeneity of the variance is assumed. In case, if the variance Levian's test value is less than 0.05, it indicates that there are significant differences are there. In case if you are able to fulfill the assumption, like homogeneity of the variance is assumed, if you are satisfied that you are going to conduct independent sample t-test, you are going to conduct independent sample t-test. In case if the assumption is violated, if the p-value is less than 0.05, means homogeneity of the variance is not satisfied. In that case, we are going to take the values of the Welch test. We are going to take the values of the Welch test. Instead of going for non-parametric test, we have one more option, Welch test, which is considered as the more robust whenever it comes to your homogeneity of the variance is not assumed, one can rely on the Welch test. I'll discuss it rest of the stuff later. Come to the data set. We have gender is one variable. Gender is one variable. We have two categories, male and female. Athlete is another category. We have non-athlete, athlete. Now, coming to the data set, we need to have two variables. One is dependent variable. Second one is independent variable. Dependent variable must be continuous data. So we have two options here. One is height is continuous data and miles per minute duration is continuous data. Now, my null hypothesis is that I'm taking two variables. One is athlete and non-athlete category. That is independent variable. We have two categories. Second one, in dependent variable, I'm taking miles per minute duration. Means I just want to know whether the person belongs to athlete category and non-athlete category. Are they having any kind of difference when it comes to going for number of miles per minute duration? My null hypothesis is that there is no significant differences between athlete and non-athlete category when it comes to the number of miles per minute duration. Whereas my alternative hypothesis, there is a significant difference between athlete and non-athlete category when we compare with the number of miles per minute duration. Now, as I just want to conduct it. So we're not going to conduct a normality test. I'm sure all of you knows about it, right? How to conduct the normality test. Okay. Now we are going directly to conduct independent sample t-test. We are going to conduct independent sample test. Now, in order to conduct the independent sample t-test, please go to Analyze. Please go to Analyze. First option, we have Exploration. Second option, we have t-test. Please select the t-test. Please select the t-test. Professor Chandra Kumar. So please select the independent sample t-test. Now, we have selected independent sample t-test. Now you can see that middle of the window is a data processing window. Here we have to select the variable. Mile for minute duration is a dependent variable. It is a continuous data. We are assuming that data is distributed. I'm not conducting normality test. Okay. If you want to conduct it, we can here also we can conduct it. So I have selected mile for minute duration and a dependent variable. Athlete and non-athlete category. That also we have it. So we have two categories. There is independent variable. So I'm going to keep athlete and non-athlete as a grouping variable. Okay. Now coming to the results here. Please look at the bottom. So right now we got independent sample t-test result. Now coming to the test, we are conducting t-test, that is independent sample t-test. By default is already there, t-test. I want to understand mean difference. Is there any difference between athlete and non-athlete? If there is a difference, how much difference we have it? Second one, I also want to know confidence interval, 95% confidence interval. That also we got it. Second one, I'll talk about it. Effect size. Just right now for timing, just click on the effect size. Just click on the effect size. Then descriptives. Just click on the descriptives. Just understand whether data is distributed normally or not. Okay. So we got normality distribution. Our data is not distributed normally, but still we are going ahead. Okay. Right now, don't consider this one. But as a researcher, one has to report whether your data is distributed normally or not. That is one of the important steps. Now, homogeneity of the test. We have to conduct a homogeneity of the test. QQ plots. Okay. Now, what you can do, just unclick normality test and unclick QQ plots. We are going to look at three data results that we got it. First one, whenever you start writing your data analysis part after completion of any of the tests, first you should talk about basic statistics like descriptive statistics. So first you should give the overview of what is our data that you have collected it, how many people are there, what are the differences we have. Let me choose height. I'm just choosing the height instead of miles per minute duration. Now looking at the athlete and non-athlete category. The people belongs to athlete category and average height is 69.3. The people belongs to athlete category. They belongs to their average height is 69.3 inches. Whereas the people belongs to non-athlete category and average height is 67. Now I want to see whether are there any differences. Now when it comes to the differences, I can able to see that 2.24. Don't worry about the minus plus here. It depends on the how you are putting the values. That way it makes a difference. Now difference is between athlete and non-athlete categories 2.24 inches. 2.24 inches difference we have between the athlete and non-athlete category. Now I just want to know what are the difference that I'm seeing it, whether it's statistically significant different. So in order to understand whether these particular results are happened by chance or there's statistically some difference, one can able to see that. Now looking at the p-value, I can able to see that p-value is less than 0.05. It means there is a statistically significant difference between athlete and non-athlete category when it comes to their height. Now one important point here one has to see. What is that? Before going to the conclusion, one has to see results of the homogeneity of the test. What I mentioned here as a part of the homogeneity of the test, the Levian's test not statistically significant, means it should not be statistically significant, means our p-value should be greater than 0.05. If you look at our homogeneity of the test, our value is 0.08, means it is greater than 0.05. It means it is not statistically significant difference, means we are assuming that there is equal variance among the groups. Please look at here. The Levian's test was not statistically significant, means our p-value is greater than 0.05. Therefore, this indicates that our data satisfy the assumption of homogeneity of the variance, means we are assuming that our data is distributed normally, means we are satisfying the homogeneity of the variance. So we are going to take the results of students test. Okay. Now we are going to take the results of this particular test. Now, hypothetically, imagine that our assumption Levian's test value is less than 0.05. Hypothetically, imagine that this particular value is less than 0.05. Now, instead of taking the t-test value, we are going to take the values of Welch test. Welch test, again, here it is less than 0.05, means there is a statistical difference between male and female when it comes to their height. We got confidence interval, we got p-value, significant results. But still, if you want to highlight your findings of the study, you got significant results, but how much effect it is, how much effect size it is there. So in order to talk more in clarity, if the effect size is less than 0.05, if the p-value is less than 0.05, it indicates that medium effect. It indicates that, for example, an effect size, effect of 0.05, it is a medium effect. If it is less than 0.02, it is a small effect. If it is less than 0.05, it is a medium effect. If it is between medium and greater effect, that is less than 0.08, it means great effect. So one more line, one can able to add it as a part of your conclusion part. Next one, paired sample test. It is a parametric test. It compares the means of two measures taken from the same individual or same object or related items. Now, when it comes to the paired sample test, it compares the means of two measurements taken from the same individual. For example, imagine that he's collecting data from his students and is taking their results, test results, like max score, science score. Max score, math score, and science score. These are the two incidents. These are the two subjects score. And you want to measure it. Are there any difference between math test score and science test score? Now we have Dr. Chandra Kumar, and he wanted to understand before attending this particular Jamovi training program. Imagine that he was attending some faculty development program, and he wanted to see what kind of improvement he's having it as a part of the feedback from his students. As you can see at the year ending, most of our institutions, they'll take feedback from the students to assess the performance of the faculty members. In addition to your contributions in terms of publications, in terms of your research writing, whatever it is, projects and all, They'll also collect the feedback from your students. Now, before attending faculty development program, and what was the teaching style that you have it, and you got the color, you have collected data from your students to understand how you are teaching it, what kind of pedagogy that you have included it. After attending some faculty development program about educational pedagogy, teaching pedagogy, generally different kind of usage of various tools. After attending the program, again, you're collecting data from your students. So you want to understand pre-intervention, post-intervention. You want to see the impact of your intervention, how effective this particular intervention is there. Maybe, for example, if somebody is coming from sociology, some psychology, from psychology people. So you must be using some psychological interventions, some counseling techniques, some intervention strategies. Before giving intervention, after giving intervention, you want to see whether is there any kind of impact on your clients in terms of their psychological behavior, in terms of their understanding about their life. So it depends on the context. One can able to conduct pre-intervention, pro-intervention test. Means you are collecting data one time before the intervention, and you will be collecting data after giving the intervention. Means you try to see the difference between pre and post. So that can also be one kind of context for conducting paid sample t-test. Dependent variable must be continuous data. We require dependent variables that must be two continuous data, and normality distribution of the data, a random sample of the population. There should not be any outliers. Now, what you have to do is here, you have to test the normality test. We all know how to conduct the normality test for that, right? Now, we are going directly to conduct paid sample t-test. And within that, there is an option called paid sample t-test. Select paid sample t-test, and you can choose the options pre-test, and post-test. So we got the results here. Now, t-test results, we are going to go ahead. I want to see the mean difference between pre and post. I want to see the confidence values, confidence interval results. I also wanted to see the effect size. I also wanted to see the descriptives. Okay. Now, coming to the results, we have two results. First one is the descriptive. There are total 20 respondents. If you look at the marks, if you look at the feedback, what are we called? Marks of feedback. Before the intervention, you collected data from your students. Mean value is 18.4. After going for the training, after going for some intervention, after giving some intervention, post-intervention marks are 20.40. Post-intervention results, 20.4. Now, this is the mean value one can able to understand. Now I can able to see there is a difference. How much difference? 2.05. 2.05 is the mean difference between pre and post intervention marks results. One can able to see that. Now I just want to know whether this particular 2.05 marks is occurred by chance, whether statistically significant difference we have it. Now if you look at our p-value is less than 0.05. It means whatever you are seeing 2.05 mean difference, it is statistically, there is huge difference between pre and post marks results. So welcome back to the fourth day. As a part of today's session, we are going to talk about one-way analysis as well as quasi-square test. The difference between independent sample t-test and one-way analysis is that when it comes to independent sample t-test, we'll have two groups, like for example, gender, male, female. Whereas when it comes to one-way analysis, we are going to have more than two groups, like male, female, transgender, like urban area, rural area, semi-urban. Like for example, so if there are more than two groups, one can go with one-way ANOVA analysis. Data requirement. Just like independent sample t-test, we need to have two variables. One is dependent variable. Second one is independent variable. Now, when it comes to independent variables, there must be more than two categories. Just like any other parametric test, independence of observation, random sample of data collection is another important aspect, normal distribution of the data. So these are the three common factors. These are the three common assumptions for any parametric statistical test. Okay. Now, even yesterday, we have discussed about homogeneity of the variance. As a researcher, we are assuming that what are the groups that you have it, whether it's male, female, transgender, what are the changes that you're seeing in terms of their performance? You are assuming that there is equal variance among the groups. All sex role type employees' performance means are equal. As a researcher, you are assuming that irrespective of their sexual type, whatever he or she feel about their sexual orientation, sexual role type, the employees' performance are equal. Yeah, everyone? Those are at least the people, those are working along with me.
Yes, sir.
Shall we go ahead?
Yes, sir.
Yeah, please. Now, our hypothesis is that, just look at our hypothesis. All sex role types employee performance means are not equal. Means there are two categories, there are two variables. One is sex role type, second one is employee performance. That is leadership performance here. Now, just look at the data. What kind of data we have it? Go to variables. We have gender, masculine sex type, performance, sex role type, and leadership style. Now, just go to data. We are going to look at performance of the employee. We are going to look at the performance of the employee. Second one, performance of the employee is a dependent variable. It is a continuous data. I mean, that is as a scale data, we have it. Second one, we have sex type. In sex type, just double click on it. You can able to see there are 4 categories of sex role type. So I'm able to check my data. I have coded correctly. It is a sex role type, androgenesis, feminine, masculine type. Then performance of the employees. It is not a decimal. So it is integer data. In order to prepare the overview of the data, go to analyze. Go to analyze. We have first option called exploration. Just click on exploration. We have the concept called descriptives. Under the exploration, the first option is descriptives. Please click on descriptives. Please click on the descriptives and click on frequencies. Click on frequencies. So we are taking 2 variables. One is dependent variable, second one is independent variable. Now here, sex role diffuse, is it independent or dependent? Sex role diffuse.
Independent, sir.
Independent variable. Okay. So sex role type is independent variable split by. Next one, performance is dependent or independent?
We assume dependent.
Dependent variable. Okay. Now we got the data here, descriptives. As I mentioned yesterday, now this particular data is presented in the form of column wise. You can choose how you want to present this particular data. I want to present this particular data in the form of rows wise. Okay. Now, next, go to statistics. We are going to conduct one-way ANOVA test. Go to analyze. Go to analyze. There is option called ANOVA. Just click on the ANOVA. Now, our dependent variable is performance. And our independent variable is sex type. Okay. Our dependent variable is sex type. Now, when it comes to yesterday, as a part of independent sample t-test, as a part of paid sample t-test, there was an option called effect size. But when it comes to Jamovi, in Jamovi software, as a part of effect size, we have 3 options. There is a last option called omega, W square. This is called omega. Please select omega. Please select the omega square. Next. Come to the assumptions. Come to the assumptions. Please click on homogeneity test. Please click on the homogeneity test. Now, please look at what is our assumptions. We are assuming that there is equal variance among the all the 4 groups. We are assuming that there is equal variance among all the groups. Now, as per our homogeneity of the test, if our p-value is greater than 0.05, if the p-value is greater than 0.05, it means homogeneity of the variance is not. If it is less than 0.05, homogeneity of the variance is not assumed. But if the p-value is greater than 0.05, homogeneity of the variance I hope you're understanding. In order to satisfy the homogeneity of the variance, we are looking for Levian's test to be non-significant. It means it should be greater than 0.05. In case if our value is less than 0.05, it means equal variance not assumed. Is greater than 0.05, equal variance is assumed. Now, I request the participant, somebody is your mic, Dr. Ashish.
Acha.
Dr. Ashish. Now, when it comes to our p-value, it is less than 0.05. It means equal variance not assumed. Equal variance is not assumed here. Now, come to the next option. We are going to look at the post-hoc test. Why we are going to conduct the post-hoc test? Whenever there are more than two groups. If you look at the ANOVA test, we have less than 0.05. It means there is a significant difference between the groups. But I want to know, instead of simply saying that there are significant differences between the groups, I also wanted to know what kind of differences we have between the groups and among the groups. What kind of differences one can able to see between the groups as well as among the groups. Now we have 4 groups. ANOVA test tells us that there are differences, significant differences. Now, what are the differences between one sex type to another sex type? For that, post-hoc tells us to understand how sexual diffuse is different from the masculine sex type, how masculine sex type is different from the feminine sex type. So it will be able to differentiate between all 4 different types of sex categories, sexual types. Okay, that is going to help us here. So for that, please come to post-hoc test. We need to select independent variable and drag and drop it here, right side. I'm just repeating again. Please come to the post-hoc test. Earlier, the post-hoc text was here. We need to select only the independent variable and drag and drop it right side. Now you can see that results, post-hoc results here. Next. Now, if equal variance assumed, if equal variance is assumed, we'll go with Turkey test. We'll go with, Tukey test. Whether it is spaces, whether it is Jamovi. If equal variance assumed, we'll go with the Tukey test. But when it comes to our, as a Levian's test, our test value is less than 0.05. It means equal variance is not assumed. So in that case, one has to go with Shifty test. Okay. Instead of Tukey test, one has to go with Shifty test. Okay. Here, estimated margins, again, we have to select the sex type here. So it is going to present mean plots. It is going to present the mean plots. It is going to help us how each sexual type is different from the other in terms of comparison. I'm going to discuss about it. Now, coming to the data sets, try to understand one by one. Starting with, we already discussed about it. Now, when it comes to the independent samplability test, I clearly mentioned how we are going to calculate effect size. If it is something less than 2, it is going to be small effect size. If it is less than 0.2, it is going to be small effect size. If it is between, if it is less than 0.5 means medium effect size. If it is less than 0.8 means 5 to 0.5 to 0.8 means greater effect size. That was part of independent sample test. Now, when it comes to the omega, it has to be between 0 to 1. One can see 0 to 1, 0 to 1. The more close to the 1, it is more effect size. The more close to the 0, low effect size. Right now, if you calculate, for example, if you take it 100%, it is 0.33, means it is a small effect size. There is a small effect size, we have it. Now, coming to the post-hoc test. Looking at the descriptive statistics, we are able to understand that there are differences. Please do it. In case if you hang it, it's fine. But from my side, I have deleted it. There is a reason. Okay. Now I'm able to see that. In descriptives, we understood that there are differences in terms of the mean value. We got some clarity that compared to any other group, androgenesis is having higher performance. Now, ANOVA test is helping us to understand not only between to understand how much difference we have it, how each, for example, sexual diffuse versus masculine sex type. If you look at the post-hoc test analysis, please look at post-hoc test analysis. Test help us to understand differences between the each group. For example, here I can able to differentiate how much difference one can able to see between sexual diffuse minus masculine sex type. How much difference we have it? Minus 2.98. If you calculate manually, sexual diffuse score is 3.41. Masculine sex type is 6.39. If you do it minus, you will get this particular figure, that is minus 2.98. Similarly, sexual diffuse versus feminine sex type, that is 3.41 minus 5.06. If you do that, you will get this particular minus 1.65. I hope you are able to understand. Is it clear so far? You are not only understanding which sexual type is having higher performance, you're not only understanding how much we can able to see differentiate between one sexual type to another sex type, how much difference we are able to have it. Okay. Now, next one. After conducting post hoc, please come to the estimated marginal values. Estimated marginal values. Now here we have sexual type. Please add it. And you're not only presenting data in the form of table as a part of post hoc analysis, we are also able to see in terms of mean plots. This is nothing but mean plots. Now, this is a sexual type, sexual diffuse, which is having least performance. This is the androgenesis, which is having highest performance. So one can able to see with the help of the plot how performance is y-axis and sexual type is x-axis. So we can able to chi-square test. As a part of chi-square test, we have two different statistical tests. One is chi-square goodness of fit test. Second is chi-square test of independence. Now, basically, we use chi-square test as a test for categorical data. Whenever we have categorical data, ordinal data, like a nominal ordinal data, we are going to conduct chi-square test. Within the chi-square test, we have two tests. One is goodness of fit test. Second is test of independence. Now, when it comes to the test of independence test, whenever we have two categorical data, we are going to use test of independence. Whenever we have one categorical data, it can be nominal data, it can be ordinal data, we are going to have goodness of fit test. Let's see one by one. First, we'll go ahead with a chi-square test of independence. As I mentioned it, when it comes to the test of independence, we should have two categorical data. We must have two categories. For example, gender, male, female, and secondly, income category. That also we have categorical data. So one can go with conducting chi-square test, that is test of independence. Coming to the hypothesis, respondents' gender is not associated with ICT competencies. If you look at our data, there are two variables. One is gender. Second one is ICT competencies. Now we are assuming that respondent gender is not associated, means whether you belongs to male category, whether you belongs to female category, is not having any kind of association with what kind of competencies he or she is going to have it. That is my null hypothesis. Whereas when it comes to my alternative hypothesis, respondent's gender is associated with ICT competencies. So this is my alternative hypothesis. Please open your data. As for our hypothesis, we have gender. Just double click on it. So we have two levels. Okay, male 1, female is considered as a 2. Okay, integer, nominal, that is fine. Next one, we have ICT competencies. So we have two categorical data. One is gender, second one is ICT competencies. We have presented as a ordinal data. It is a ordinal data. We have presented in the form of some ranking, some kind of position, like low, average, medium, low, average, high. So this is ordinal data. Please ensure that we are going to make changes. Second one is a data type. It is integer data. Okay. Now I'm fine. I'm very confident about what kind of data that I have it. Now coming to the total number, it is around 220. No, we got around 656 responses. We have it. Okay. So after understanding the data, we got some kind of clarity that we have good sample size and we have two categorical data, and each categorical data is having more than two. Like for example, gender is having two categories, male, female, and ICT competencies, ordinal data, it is having more than two categories, right? Or two categories. Now go to analyze. Go to analyze. There is option called frequencies. I hope one can able to see there is option called frequencies. In the frequencies, we have independent samples, that is chi-square test of association. Chi-square test of association. I'm just repeating again. Please go to frequencies. If you scroll your cursor, one can able to see there is independent samples. Under that, we have chi-square test of independence. Please select chi-square test of association. Very simple test. One of the most simple tests. Okay. Now, our two variables are gender is one variable. Second one is ICT competencies. So I'm taking gender as a row wise and ICT competencies as a column wise. Okay. ICT competencies as a column wise. You can also take it other way also. There won't be any issues. Okay. After taking these particular variables, go to statistics. Go to statistics. By default is already selected chi-square test. By default is already selected chi-square test. Okay. You can select a likelihood ratio, though we're not going to talk about it. Just ensure that you're going to select chi-square test. Okay. Confidence interval 95%. Confidence interval 95%. There are two things here, pi value and Karmer value. When you are doing a chi-square test in S spaces, if you're going to have 2 into 2 table, we are going to use the values of pi values. In case we are going to have 2 into 3 table, for example, right now we have 2 into 3 table, like 2 into means male, female, and 3 variables, low, average, height, means it is called 2 into 3 table. But imagine that there are only 2, low and height. It is called 2 into 2 table. If you have 2 into 2 table, you are going to use the values of the pi values. In case we are having to have 2 into 3 or 3 into 3, in that case, you are going to rely on the Karmas value. But as I mentioned it, as Jamovi is still they are developing on it. At present, we don't have values of the pi values. Whatever you do it, we are going to take the values of the Karmas value. We are going to take the values of the Karmas value. Next, please come to the cells. Please come to the cells. Please click on expected counts. Please click on the expected counts. And you can choose whether you want to go with row wise, column wise, at least one of the option. How you want to prepare the frequencies. Okay. Next one, please come to the plots. If you want to prepare any kind of bar chart, as it is categorical data, if you want to prepare any kind of bar chart, you can also prepare it. Okay. If you want to keep in percentages that charts, you can also prepare it. How you want to prepare it. Okay. As we have taken column here, I'm also taking the x-axis columns. Okay. Now, please try to understand what kind of data we have. We have males and ICT competencies. Yeah. Now, when you look at the observed frequencies, who is having high ICT competencies category? They have low ICT competencies. Average wise, male having highest number of people are having high competency as compared with their female. When it comes to high level of ICT competencies, if you compare with the females, males having high level of high competencies. Okay, that is one thing. Point number one. Now, looking at the differences, I just want to know whether these particular differences occurred by chance or whether it is statistically difference. If you look at the chi-square test value, it indicates that our p-value is less than greater than 0.05. It means, though we are able to see there are differences between the male and female in terms of ICT competencies, but what are the differences that we are seeing it? What are the associations? But they're not very significant. Means one cannot say that there is an association between gender and ICT competencies. The conclusion here is that there is no association between gender and ICT competencies. As our p-value is greater than 0.05, it is 1.12. Okay. Now, as it is, our p-value is greater than 0.05, we don't need to talk about Karma's value here. Basically, Karma's value talking about effect size, how much effect it is there. We are going to talk about pi value or Karma's value whenever we're getting chi-square test value significant difference. But as chi-square value is greater than 0.05, so there is no point of talking about Karma's value here. Okay. Now you can also see the bar chart that we have created it here. So this is one of the simplest tests. I hope it is clear to all. Correlation test. Correlation test is a part of the parametric test, a statistical technique that is used to analyze the strength and direction of the relationship between two quantitative variables. Now, previous classes, so far we have discussed about comparison-based test, like independent sample t-test, one sample t-test, paired sample t-test. It was comparison between different variables. Whereas when it comes to ANOVA test, whenever there is more than two independent groups, we have used one-way ANOVA, and we also conducted two-way ANOVA, and we also conducted chi-square test. Whenever we hang two categorical data, we have conducted a chi-square test of independence. Whenever we hang only one categorical data, we have conducted chi-square goodness of fit test. Now, as a part of this particular correlation test, we are going to see relationship between two quantitative variables. Now, the point here is that as a part of the correlation test, we have different types of tests like Pearson correlation, Spearman correlation, partial correlation. So we are going to look at each test one by one. I'm repeating again. Pearson correlation is a part of the parametric test. Right now, I'm discussing about Pearson correlation. If we are going to conduct Pearson correlation, we require two quantitative variables. Okay. Two quantitative variables are required. Now, the main objective of conducting Pearson correlation is to analyze the strength and direction of the relationship between two quantitative variables. If you have interval data, ratio data, one can conduct Pearson correlation. Just like any other test, we also have certain parametric assumptions. As a part of the parametric test, one has to fulfill certain assumptions. Now, the main objective of the correlation is that I mentioned that strength and direction. Strength in terms of whether it is positive correlation or negative correlation. Similarly, one of our assumptions is that there should be linear relationship. Whether it is positive or negative, one can call it as a linear relationship. In case, if there is no relationship, you cannot call it as a linear relationship. For example, demand increases, price increases. One can able to see positive correlation. Means if a value of one variable increases, the value of other variable also increase. That is called positive correlation. It is also known as linear relationship. Means one variable increases, other variable also increase. If you look at the second middle of the image, negative correlation. If one variable increase, other variable decrease. This is called negative correlation. But it is also linear relationship. The value should be between 0 to 1. If it is more close to 1, the value should be -1 to +1. So based on that, we are going to discuss about it, whether it is having positive correlation or negative correlations. At the time of interpreting the data, I'm going to show you the certain values, how we are going to write as a part of our data analysis, how we are going to interpret the findings of the correlation. Okay. Now, when it comes to the problem of the statement, as a part of our null hypothesis, there is no correlation between master score and reading ability of the students. Now, as a researcher, you are assuming as a part of your research, you are saying that as a part of your null hypothesis, there is no correlation between math test score and reading ability of the students. Now, when it comes to our alternative hypothesis, there is a correlation between math test score and reading ability of students. Please take your data set. Please take your data set. Now, I'm just going to import the data. Go to File menu. Just click on Open. Name of the file is correlation. Name of the file is correlation1. They have given two different files. So we are going to practice two different data sets. Just open correlation1. The title of the file is correlation1. I believe those are working along with me. You are ready with your data set.
Sir, is the recording possible on?
Yes, the record is going on, sir. Yes.
Thank you, sir.
Don't worry about it. Yes, madam will. I'll give it to madam. She will send you back. Okay. Yeah. Yes. So we have opened the data, and we have three variables after excluding the ID: math test score, reading ability, and intelligence. Now we have around 35 responses. Here. Now, as a part of conducting correlation test, we need two quantitative variables. We have three different variables. Right now, we'll take two quantitative variables as per our null hypothesis. We are looking at the difference between relationship between math test score and reading ability. Okay. Now, in order to conduct the correlation between these two variables, one of our data assumption is normality distribution of the data. One of our assumptions is normality distribution of the data. Okay. So in order to conduct the normality distribution of the data, and we also need to see, second point, we also need to see is there linear relationship, whether we have positive correlationship, whether we have negative correlationship. So in order to understand the linear relationship, we have one important plot. Name of the plot is scatter plot. So please go to analyze. There is option called exploration. In that we have first option, scatter plot. Please select scatter plot. Please select the scatter plot. This particular scatter plot is available in analyze, explore. First option is scatter plot. Okay. Now we are looking at the linear relationship between two different variables, two quantitative variables. Now, when it comes to the correlation, I'm not concerned about independent variable, dependent variable here. Okay. So I can choose randomly x-axis and y-axis wherever I want to keep it here. Okay. Okay. As a part of the correlation test, one need to worry about which is independent variable, which is dependent variable as a part of the correlation test. Now, here one can able to see that we have prepared the scatter plot. In case if you're not able to understand how to read it, as you can see left side, the middle of the window, we have regression line. Right now, it is showing none. Just click on the linear relationship. Now one can able to see diagonal line here. Now how to understand this particular scatter plot? From the layman point of view, I have one point here. If you look at the right side bottom, we don't have any data. Right side bottom, we don't have any data. Similarly, on top side, top left side, we don't have any data. It means, for example, somebody's got maths score starting from 0 to 60. Okay. Now it means as maths score is increasing, reading ability of the score is also increasing here. If somebody want to say that maths test score is increasing, reading ability score is not, reading test score is not increasing, it means you will find a lot of score here. You would have find a lot of score, a lot of distribution of the data here, but we are not able to find any kind of data here. It means maths test score increase, reading ability also one can able to see there is increase here. For example, the person here, roughly around 56, 55, 56. The person who is having around 56 marks, here she is having around 25 reading ability test. 25 reading ability test. Similarly, the person who is having marks 51, the number of people those having marks 51, they are having reading ability around above 15. Okay. Now, what I mean to say that there are no points, there is no distribution of the results, right side bottom, on top side left side. It means if one variable increases, on the other variable also increases. One able to understand this particular curve, it is a positive correlation. Just look at my screen here. We have one is positive correlation, means if one variable increases, other variable increases. Now, there also can be negative relation. Okay, as a part of linear relationship, one can also see negative correlation as well. It means one variable increases, other variable decreases. But in our case, the data that we have with us here, it is a positive correlation. We have it here. Okay. Now, if somebody want to use it extra, like for example, if you want to keep it smooth, so one can able to better understand how it is data is distributed, right? Now, after understanding the one of our assumption, whether we have linear relationship or not, one can go with conducting correlation test. Next, go ahead with analyze. As a part of the regression, please just click the regression option. We have correlation family as well as regression families here only. If you want to conduct either correlation or regression, one has to go for regression test. As a part of the regression, we have first option is correlation matrix. Correlation matrix. Please click on correlation matrix. Now take the variables that you want to conduct the correlation test, math test score and reading ability. And as I mentioned it, if you are able to fulfill the data assumptions like normality distribution, I think we haven't conducted normality test. Let me go back to exploration, descriptives, and I'm taking both the variables to see bivariate normality distribution, and go to statistics, select whichever you want it, and you can unselect whichever you don't want it. Okay, so we have sample size, mean value, Sperry-Wilkie test. So to understand the normality distribution of the data, I just want to see the data in the form of row-wise variables across the rows. So as a researcher, one can able to make changes as per your choice. Next, in addition to Sperry-Wilkie test, I also wanted to present some plots like histogram, QQ plots. Okay, so just to understand whether my data is distributed normally or not. Now just come to the Sperry-Wilkie value. Our data is greater than 0.05. Our data is our p-value is greater than 0.05. It means our data is distributed normally. Our data, both the values are greater than 0.05. It means our data is distributed normally. Right? So we have confirmed the second assumption as well. And we also got the descriptive statistics. Now, there are total 35 respondents. When it comes to the math test score, on average, people got 54.6. Their mean score is 54.6. Whereas when it comes to the reading ability test, they got average score 16.7. So this is our basic understanding of the descriptive statistics as well as normality distribution of the data. In addition to the Sperry-Wilkie test, one can also look at the histogram, and you can also see the normal QQ plot test to understand whether are there any outliers. Now, after having understanding about linear relationship, normality distribution of the data, and having basic descriptive statistics, now third step, we are going to conduct correlation test. I'm going very slow. Please still stop me if there is an issue. Okay. Now, in order to conduct the correlation test, please go to regression, and there is a first option, correlation matrix. There is a first option, correlation matrix. As for our null hypothesis, we are selecting the two variables. We are saying that there is no relationship between master score and reading ability as a part of our null hypothesis. So I'm taking both the variables. As I mentioned it at the beginning of the session, we have three types of tests within the correlation test. One is PSN correlation. Second one is the Spearman correlation. Third one is Candela test. Now, when it comes to the PSN correlation, we will use it whenever we are able to fulfill our parametric assumptions. In case for the same data set, both the quantitative variables, but if you're not able to fulfill the assumptions, so one can go with Spearman correlation. Spearman correlation and Candela test, they are non-parametric test. So at least we can use Spearman or Candela test, any of the non-parametric test, if you're not able to fulfill the parametric assumptions. Okay. Now, as we are able to fulfill our assumptions, parametric test assumptions, we are going ahead with conducting PSN correlation. Now, Additional options. There are certain additional options. We got the significance, we got the results of the correlation test. I also wanted to get some kind of indication. Okay. As you can see here, the moment I click on flag significant correlation, we are getting the star asterisk. It means it shows the strength of the relationship. We have it. It shows that as p-value, you can see that it is less than 0.05. It means there are significant relationship between match the score and reading ability. So the way how one can analyze it, whenever there is a match the score is increasing, the reading ability of the students also increasing it. So there is a significant relationship between these two variables. In addition to talking about direction of the relationship, one can also talk about strength of the relationship. What is the strength here? It is 0.787, means nearly 78%. 0.78. As you can see this particular slide, looking at our results, we got our results 0.78. It means it is between 0.70 to 0.90. It means high positive correlation. Imagine that in case we are getting minus 0.78, it means it between minus 0.70 to minus 90. It means high negative correlation. So it depends on the plus and minus symbol. One can able to decide whether it is a positive correlation or negative correlation. Next one, we have regression test. Within regression, we have two types of tests. There are so many regression tests we have it. As a part of this particular workshop, we are going to discuss about simple linear regression, multiple linear regression. Simple linear regression means if you have one independent variable, one dependent variable, we are going to conduct simple linear regression. Multiple linear regression means if you have one dependent variable, more than one independent variable. In that situation, one can go for multiple linear regression. Now, second important point, the difference between correlation and regression. As a part of the correlation test, we are able to tell strength and direction of the relationship between two different variables. Whereas when it comes to the regression test, in addition to strength and direction of the relationship between two variables, one can also able to say cause and effect relationship. Whereas when it comes to correlation, one cannot simply say, we are able to assume there is a relationship and we are going to test it. But 100% we cannot say that this is because of this one, this is happening. One cannot able to say cause and effect relationship between two different variables as a part of correlation test. But when it comes to regression test, one can able to predict just because of this particular variable, this is happening. Let's take for example, the sales manager would like to assess if sales force training results in reduction in losses. Now, as a sales manager, you want to understand what are the training that you are going to give to your employees. You are going to spend a lot of time, a lot of resources, and you are going to conduct training program for your employees in order to improve their sales performance. Now, conducting training is an independent variable, and its impact on the sales performance is a dependent variable. Now, coming to the assumptions, as a part of simple linear regression test, just like correlation, we have to have linearity. Second one, homoscedasticity, I'm going to talk about it. Rest of the two are common, like earlier also we have discussed about it, bivariate normality, independence of observation. Now, the new point here as a part of regression test, especially as a part of simple linear regression, is that homoscedasticity test. Homoscedasticity. Now, as you can see, one of the scholar has given this particular image. I thought it is going to help us to get more easily. Name of the scholar is Edwin Benny. He nicely presented the assumptions of linear regression with the data visualization tools. Okay. So he presented in the form of data visualization, except point number 5. I'm just repeating, very important. As a part of simple linear regression, except point number 5. I'll talk about point number 5 when we are going to talk about multiple linear regression. Similarly, when it comes to simple linear, bivariate normality, not multivariate normality. So please remember point number 3, point number 5. As a part of simple linear regression, we are going to have bivariate normality. Similarly, when it comes to multiple regression, we are going to have multivariate normality. And in addition to that, we're also going to have lack of multicollinearity. So I'll be talking about this too when it comes to the multiple regression test. As a part of simple linear regression, we all know what is linear relationship. Like if one variable increases, other variable also increases. There should be linear relationship. Okay. If one variable increase, another variable decrease. That is there. The main point that we need to discuss right now here is homoscedasticity. What is meant by homoscedasticity? Homoscedasticity is the term that states the spread residuals which we are getting from the linear regression model should be homogeneous or equal spaces. If the spread of the residuals is heterogeneous, then the model is called to be an unsatisfactory model. One can easily get an idea of homoscedasticity of the residuals by plotting a scatter plot. So again, we are going to conduct the scatter plot here. Just put it more easiest manner. We are conducting the regression test. As a researcher, you have observed value. As a researcher, you also have predicted value. As a researcher, you also have observed value. You also have predicted value. The difference between the observed and predicted, what are the difference that you're getting it? As a researcher, you're assuming that the variance, the change is going to be the same. What are the difference that you're seeing it? It always remains the same. That is homoscedasticity. Homo means same. Same, scedasticity means difference. Same difference you are seeing it. Yes. If you open this particular data set, please come to last two columns. Please come to last two columns. We have two variables. First one is knowledge test score. Second one is calcium intake. Now, just imagine yourself that you're working as a dietist. You are working as a dietist and you are giving training to your clients. Those are coming and attending your program. You are conducting 5 days program, 10 days program. What kind of diet they have to take it. And having knowledge about particular diet, it is going to help them in terms of how many calories of food, how many calcium they are going to take in terms of number of milligrams. Okay. So having knowledge about diet, having knowledge about particular intake, it is going to improve the way we are going to take intake. Now there are total 50 candidates. After giving training for 1 week, and you ask them to come after 1 month, and you ask them to check it on average. Okay, so now we have test score. We have conducted marks. You have conducted the test. Those who attended your training program for 50 marks. Those who attended your training program, we have conducted test for 50 marks. There are respondents who got 10 marks out of 50. There are respondents who got 42 marks out of 50. So one can able to check it manually. There is also one candidate, he got around 48. Okay. Now on the other hand, one more variable is we have calcium intake. Calcium intake in terms of number of milligrams per day. I'm just repeating again. One is test score for out of 50 marks. Second one, calcium intake in terms of milligrams per day, number of milligrams per day. So this is our problem. This is our trying to understand whether knowledge is having any kind of impact on calcium intake. Whether knowledge is having any kind of impact on calcium intake or not. That's what we are going to do that part. Now, one of our first assumption is that one of our data requirements is that as a part of simple linear regression, we need to have one dependent variable, one independent variable. Now, till now, we haven't discussed about dependent here. Whereas when it comes to the regression test, I'm talking about which independent variable, dependent variable, because we are able to see which is predictor and which is having impact on. Because of predictor, we are able to say what kind of impact we are going to have on dependent variable. So knowledge is an independent variable. Calcium intake is a dependent variable. So I just want to know the person who is having higher knowledge, how much milligrams of calcium intake they're having it, whether this knowledge is having any kind of impact on calcium intake or not. That's what I want to check it out. So we have two variables. One is knowledge and calcium intake, independent, dependent variable. Second one, what kind of linear relationship? So we need to go for conducting scatter plot. In order to understand what kind of relationship we have it, one has to go for conducting Scatter plot. How to conduct a scatter plot? Go to Analyze. Go to Analyze. There's a first option called Exploration. We have Scatter plot. We have scatter plot. Please scroll your cursor and please select the variable, that is knowledge test score, as a independent variable, that is x-axis. Knowledge test score is the independent variable, so I'm going to put it under x-axis. Calcium intake as y-axis. Calcium intake as y-axis. Now, as I'm not able to understand, so I just want to see in terms of non-regression line, I want to see linear regression, and I also can take the help of smooth. So I can able to understand, I can able to read it properly. If one variable increases, other variable increasing, especially if knowledge test score increases from 0 to somewhere, I think we have seen one score 48. It must be around 48, right? If knowledge test score is increasing it, calcium test score also increasing it, right? As I was able to tell you one clue point, very hint. Bottom right side, we don't have any kind of data. Similarly, top left side, we don't have any kind of data. It means one variable increases, other variable increases. One can able to see that all the data is distributed across the diagonal line. There is no much variation, there is no much deviation from this particular diagonal line. It means if one variable increases, other variable increasing. It means linear relationship. There is positive correlationship. One can able to see that. After understanding this, just go to again exploration. Go to descriptives. Step number 2, look at the descriptives. Take the knowledge test score and calcium intake. You can keep it across the rows and go to statistics. You can unselect whichever you don't want. You can select whichever you want it. Like for example, mean value, I got it. Now I want to see, if you look at the out of 50 score, knowledge test score, mean score is 29. Out of 50, 50 was maximum, that is, right? 50 marks. And your average score is 29. Knowledge test score average is 29.1. When it comes to calcium intake, on average, mean value is 776.2. Okay, this is the average number of milligrams per day. On average, 50 respondents are taking it. So after understanding the linear relationship, after understanding the basic descriptive statistics, I just want to know whether my data is distributed normally or not. I just want to know whether my data is distributed normally or not. Now, when it comes to we should have bivariate normality. Means, as a part of this particular data, we are having two quantitative variables. If you hang two quantitative variables, one has to check the bivariate normality. For example, in this particular case, knowledge test score, it is greater than 0.05. It means our data is distributed normally. Whereas when it comes to calcium intake, it is less than 0.05. It is 0.02. It means it is less than 0.05. It means our data is not distributed normally. But as a part of the exercise, we are going ahead with it. But in case, when it comes to as a part of your thesis, as a part of your paper, if you're going to do that, please ensure that one cannot go for heading conducting simple linear regression test. Okay. Now, after understanding that our data is distributed, checking the normative distribution of the data, please go to regression. Please go to regression. There is a first option, linear regression. There is third option. Within regression, first option, linear regression. Linear regression. So here, my variables are knowledge test score is covariance. Calcium intake is dependent variable. Now, one can able to see model fit here. Before going directly to results, just come to here. Assumptions, please come to the assumptions. We already checked with the normality. We also checked with the QQ plots, but still you can check it here also. Residual plots also you can check it. I'll talk about it later on. Auto correlation test, collinearity test, and Cook's distance. I'll be talking when it comes to multiple linear regression. As a part of simple linear regression, we already conducted normality test, but still if you want to take it, you can take the values. You can take the values, normality test. This is bivariate normality test. Okay. Residual plots, you can take it. I'll talk about it. Model fit, please come to the model fit. Overall model fit, there is ANOVA test. We are going to get it. We are going to get the ANOVA test. R value, R square value. I'll be talking about adjusted R square later on. As a part of simple linear regression, R value, R square value. Coming to the model coefficients. Standardized estimates. Confidence interval. I'll be showing you later on after some period of time. I'll talk about what is saved. Okay. Now, please come to the data values. Please come to the results. If you look at our linear regression test results, our test value is less than 0.05. It means there is a significant difference. There is a significant relationship between knowledge test score and calcium intake. If somebody's knowledge increases, it means calcium intake is also increasing. It is a very significant relationship we have. In addition to that, one can also see the correlation test result here. Test value is, our correlation test result is 0.89. It means if it is 0.9 means high positive correlation. As it is 0.896, it means I can keep it round off. It is a 0.90. Basically, it is a 0.90. Means high positive correlation we have between knowledge test score and calcium intake. High positive knowledge test score and calcium intake, we have it. Now, we are going to take the values of the R square test when it comes to the reporting it. There is one more value, adjusted R square. If you have more than one independent variable, in that case, you are going to take adjusted R square. But when you have only one independent variable, you are going to take the values of R square test value. R square means it is a honest value as compared with the correlation value. So we are going to take the relationship R square value. Now what it indicates? 0.80. It means as a researcher, you are able to predict 80% of the variance, whatever you are seeing in terms of calcium intake, that is due to change in knowledge test score. I'm just repeating again. At the beginning of the session, I mentioned that as a researcher, you are not only going to talk about strength and direction of the relationship, you are also able to tell, cause and effect relationship. As a part of independent variable, as a predictor variable, you are able to predict just because of this particular variable, this kind of change you are able to see. Now, in this particular context, we are able to see 80% of the change in calcium intake due to change in knowledge test score. Means remaining 20%, there are other factors which are causing the change. But 80% is really good error, especially when it comes to social science. If it is above 50, 60, it means really is a good indication that this particular factor predictor is, you are able to predict it properly. So one can able to see cause and effect relationship between these two variables. Now, so this is a simple understanding of the linear regression. Now, when it comes to the model coefficients, when knowledge test score is 0, means 1 unit of change in knowledge test score leads to 14.4 is going to increase in terms of milligrams intake. I hope I'm able to make it sense. Is it clear to all?